Okay, well, the return of Coach Nathan to the public domain of Edward A. Goki. How have you been, man?
I've been good, busy. Couple different business ventures. On with you, taking part in Coach Peter's fitness program. Your
Yeah.
biochemistry course. I was lucky enough to be one of the selected to be part of that core group in the creation of what's turning out to be uh, very in depth and information dense, but also easily understood at the same time.
Yeah. Well, I'm glad that that's living up to that expectation and living up to that goal because that was precisely the goal that I had in mind. Taking these really complex concepts and making them as simple to understand while maintaining the necessary details and the integrity of the actual information. Because a lot of times you can chip things down to a really simple degree into really catchy, into like catchphrases basically. But then most of the time, the reason that those catchphrases are so catchy is because they necessarily have to strip detail away from it in order for
Mm-hmm.
them to be catchy. Like they can't, you're actually losing detail. So I wanted to make the course as efficiently understood as possible. And of course, we're we're in the very, very, very beginning steps still, of course,
Right.
but we're plugging away at it
Yeah.
in terms of actually creating lesson after lesson after lesson. We're really hammering that in. So I'm glad that that's living up to your expectations and also mine, but also I'm glad that you had the opportunity to become one of the 20 select members to help build it. It's as interactive as possible as well. Um, but I also see that you're wearing the
Oh,
association doesn't equal causation
yeah.
shirt. Yeah. I like your shirt.
Yeah, right. No,
Yeah.
this is in a lot of your videos. This association not equaling causation, but then also that just because there is no association does not mean that there is not causation has been
Yes.
extremely thought provoking, and kind of thrown a lot of things that I had previously believed or took as evidentiary just out the window.
Yep. The more and more, like the only time that they will actually exist in that way, like the only way that you can actually rule out causation if there's no association, and the only way that you can rule that there is a causation when there is a very strong or perfect association is in the context of a vacuum. So the closer and closer you approximate a vacuum, the more and more you can start to perhaps entertain those ideas. But
Right.
whenever you're looking at studies that have dozens upon dozens of confounding variables. And it's not just about the
Mhm.
quantity, it's also about the quality. How much influence does each confounder have? Because you can have a dozen confounding variables that only have minuscule influence. So therefore, how much total noise is there? Well, there could be
Right.
a lot less than a study that studies an association with two confounding variables that have extreme influence over the variables you're studying.
Right. Yep.
It's like that also matters. It's quantity and quality. So
Yeah.
yeah, no, there's it's such a poignant trite point that I had to make. I had to make a shirt that said that.
Right.
So I'm glad to see you representing there.
Oh yeah.
Yeah.
Um. Yeah. The shirt's great. It's definitely sparked a couple conversations amongst
Oh, really?
coworkers or family members or something. They're like, what's the deal with the shirt? And I'm like, hey, if you want to dive into it, we can. But yeah,
Right.
no,
Yeah.
it's fun. It's fun.
Yeah. Good. Good.
Um,
Well. Yeah. Yeah. So
I,
you have
I
some questions. Yeah.
yeah, I've been working on a list since our last since we jumped on our video last. But
Uh-huh.
some of them are statements, some of them were just thoughts that I mean they're literally just phrases that I just jotted down just to bring up. Um,
Yep.
but one thing, so let's just get right into it. Are you How familiar are you when it comes to HCG versus testosterone replacement therapy?
I'm not familiar. I've not heard
Oh,
of
you're not.
HCG before.
Okay. Um.
What do
So
you what do you know about it? What do you know about it? Because then maybe I
so
can give some ideas.
so there was about a year I was going through my own mental and emotional growth and stressors in my life. And that stress just completely wrecked my hormones, uh,
Okay.
wrecked my sleep patterns, my appetite, my libido, etc., etc. Um, I went and had some blood work done, found out I was low testosterone. I qualified for replacement therapy, and
Okay.
after about 4 months, I was starting to exhibit symptoms of increased estrogen production. Um,
Uh-huh.
I started
Yep.
showing very early symptoms of gynecomastia, um,
Okay. Yep.
hypogonadism. All the things that your
So
body, all the
basically
things.
you're
I'm sorry. Go
basically
ahead.
converting a bunch of testosterone into estrogen is basically what's
Yeah,
going on.
when you
Yeah.
change one variable in this balancing act of hormones.
Yeah. Yeah.
Um, but another symptom is well, with the hypogonadism, your testicles and pituitary gland, your body stops sending those signals to produce testosterone. So naturally, those parts that now are no longer working are starting to atrophy.
Right.
Um, HCG is is another is another exogenous compound that you can add into this stack. And I call it a stack because I eventually had to be on estrogen blockers while on the TRT, and then added HCG to it because HCG tells your pituitary gland and your testicles to begin producing testosterone again. So it kind of overrides that. It overrides that modulating mechanism in your body that tells you, no, we have enough. We don't have to make
Okay.
it.
Interesting. Yeah. Yeah. No, no. Continue if you have more to say, of course.
Yeah. So it was just it. If I had to do it all over again, and since then I've come off of everything, uh, got everything regulated in my life, discovered carnivore, and started going to the gym regularly. And after my body regulated after coming off of everything, my testosterone is still high, not as high as when I was taking this exogenous amount.
Right. Okay.
But my testosterone came up way up from what my baseline was when I had started. Um, but if something happened and I did have to do it all over again, uh, if I had to make a choice, I would 100% start with. I feel like I would start with HCG first and just encourage my body to produce more instead of just instead of just getting injected with a
Right.
direct synthetic exogenous um,
Right.
amount.
Yeah. So I think what you're saying is that you're targeting a lower foundational part of the hierarchy, so to speak. Like
I
you're
feel like
getting
that's what it
closer
is.
to the root when you're taking HCG as opposed to just injecting exogenous testosterone. I can tell you right now, my father is someone that still takes, and he's been taking it for, oh man, I think at this point it's over a decade at this point.
Okay.
He's been injecting testosterone once a week, and it was
Mm,
because the reason it started was because he was having an extremely high heart rate, extreme fatigue. Like he actually called
mm.
people out to look at the house because he thought that there was like a gas leak or something. Because as soon as he
Oh
would
wow.
get home and sit down on the couch after work,
Yeah.
he would fall asleep without even realizing that he did it. He was just super, super tired.
Right.
Um, and also, sort of paradoxically, he had an extremely short fuse and would be angry all the time. Like
Mm,
he would get his anger would be extremely heightened beyond what
mm,
he should normally exhibit in a certain situation, but also it would be instigated um, and provoked with very minor stimuli.
okay.
Um,
Yep.
and he went and got checked out, in terms of his testosterone. Like he got some blood tests done because he didn't know what was going on with him. He finally was realizing, he was like, something's wrong, I think.
Right.
And his general care practitioner ran some blood tests, and they saw that his testosterone was lower than that of a female's, typically,
Oh,
really low. And so they started telling him to take testosterone, and the exact same problem happened where his estrogen started getting really high.
yeah.
His testosterone wasn't budging; it was all just being converted into estrogen.
Okay.
That was basically the idea, because then they told him, okay, well, now take this other drug as well that stops that conversion of testosterone into estrogen.
Yeah. Uh-huh.
And then he started to actually see levels increase. And to be extremely fair, that fixed his issues more than anything else did. Like, it really, his mood was stable, his energy was stable. He was able to build a lot more muscle, and he lost fat naturally.
Yep.
Yeah. So he had high estrogen and low testosterone, but those were tightly, related. But he hasn't stopped. He's been carnivore, like at least meat based, for years now. But I think it's been one of those things where he's been taking the drug for so long, he's almost like worried for the change. Like, he doesn't want to make the change. Like, he's so
Yeah.
used to it that he's like, man, I've been taking this for so long. What happens? Like, what's going to happen? Like, I don't know. So I don't know. I mean, I've talked to him about it before. I've been like, hey, you probably don't need that anymore. Here's another thing that happened, and I never talk about this, ever. But if you're watching and you're a long-time viewer since the very beginning, you will remember that I used to promote a certain water machine known as the Kangen water machine, not
Oh, okay.
condom, because people will think I'm saying condom, by the
Yeah.
way. Kangen water machine. And I used to promote it not because, so if anyone is familiar with it, I don't know if you're familiar with it, if you've heard about it before, but it's promoted by a brand by the name of Enagic for being alkaline water. So it's a machine that makes, alkaline water. And it does absolutely change the pH of your water. So it goes from, you have a 2.5 pH water that you can make infused with hypochlorous acid, and it's used as sanitizer. So you're not supposed to drink that. Don't be drinking that. But then it also goes all the way up to 11.5 pH, so that you can like use it basically as a dish soap replacement, because it emulsifies oils.
Right.
Like, you can actually
Yeah.
mix it with oil, and it will mix everything. So it does work in that respect. But the main reason they promote it is because you get this 9.5 pH water, and it's alkaline water that's really good for you, and it's anti-cancer, right? Um, but when I was promoting it, I had already known about acid-base balance and pH and all that stuff, and I knew that the alkaline water did absolutely nothing except have an influence over your stomach pH for a slight amount of time.
Mhm.
But the reason that I was promoting it was actually for another reason, which was because it actually restructures the water molecules themselves into extremely small water molecules, and it seemed to make them able to hydrate your cells more than the water that is found in typical bottled water. Um, and what ended up happening was my dad started drinking that water because he was the one. Years ago, I didn't really have a job. As people know, I was extremely, I suppose you could say ill, but disordered. Let's put it that way.
Mhm.
And he was the one that bought the machine. I turned him on to the idea. He bought it, and he started drinking the water, and he got his next blood test, and his testosterone skyrocketed.
Hmm.
And that was with him still injecting testosterone to a point where his body wasn't even producing it itself.
Right.
So, I mean, a lot of people don't know that testosterone will actually, if you're taking exogenous testosterone, if the concentration gets high enough, your body won't just not create testosterone. The same pathway is inhibited that produces like sperm cells. So you'll actually, it's basically,
Mhm.
it's like male birth control, effectively.
Yep. Yep.
So that's another thing that happens. But he was basically, he knew that. And despite that, the only change he made, and this was before we were carnivore, actually, his testosterone like doubled in the absolute
Yeah.
number just by drinking that water. And I went,
And that
whoa.
was the only thing that changed in that whole scenario.
Yeah. because he had gotten tests done every year, and not just
Right.
and by every year I don't mean once a year. I mean it was like twice a year at least, just to
Right.
follow up on what his levels are looking like, so to see if they needed to adjust the dose or something like that. Because you can
Hmm.
also get too high of testosterone,
Yeah.
and that can cause issues. Um, but they they were like, "Whoa, what are you doing differently?" He's like, "What?" And he looked at the
Yeah.
level. They showed him the levels. He's like, "What the hell?" And the only thing that we could think of was that water. And I thought, well, that's really interesting. I mean, that's like, so I started promoting it because I also felt some differences in myself drinking that water. And not only that, the 9.5 pH water, as much as the pH isn't really doing anything for you, if anything, it could actually be causing your stomach problems because your stomach's supposed to be acidic.
Right.
Um, it is infused with molecular hydrogen molecules. And
Okay.
they're supposed to, there's some I don't know if it's scanty or not because I haven't delved into it too much.
Yeah.
But there is some evidence to suggest that those function as antioxidants themselves, like exogenous antioxidants that are pretty non-toxic because they're not like plant antioxidants that are doing a lot of dubious things in the body. It's just H2. It's just hydrogen.
Right. Yeah.
So I was promoting it for that reason, and then I decided to stop because I still drink that water, and I'm not going to pretend like I don't. I still that's the only water I drink. I refuse to drink any other water. But I only
Hmm.
drink the 7.0 pH water, by the way, and that does not have hydrogen infused in it. It is just restructured, and we also have pre-filters that remove literally every single thing from that water that you can think of. It goes through 4 different filtration processes before it reaches the cup. In fact, the flow
Right.
of water goes down when we turn on the faucet because it's going through so much filtration.
Right.
But the only thing that it has in there is calcium ions because it employs electrolysis and it needs an ion for the
Hmm.
electrolysis to occur. So calcium ends up in the water. So I'm getting a lot of calcium in my own water.
Right.
But I stopped promoting it very early on because I thought, well, do I think that I should be generally promoting this for a general audience if my philosophy is what is genotypically consistent? What did we evolve consuming?
Right.
I was like, no. I mean, I could promote it the same way I sort of did with I do with cerule, which is yeah, we didn't evolve consuming cerule. Okay, we didn't evolve
Right.
consuming this. However, we're living in an environment that has variables that we cannot control for in terms of
Hmm.
like like curtailing all um, problematic contraindications in our diet and all that stuff. And so, if you want an extra kick, to hedge against those,
Right.
have cerule. But I also thought I was like, you know what? I don't think I'm going to be doing that with the water because the cost to benefit ratio was not something that I was looking into. You know, I didn't think it was that generally favorable. I decided to do it from experience,
Right.
but I'm not going to tell people to spend that money on something that could have a minor benefit that may not even be noticeable. So,
Well, I
but
mean,
yeah,
and with the, I mean, with like with variables that are outside of our control.
mhm.
The it's also try. This is actually one of the talking points. After watching your video on how modern life is an experiment,
Uh huh,
um,
yeah,
I was dipping into something else. I dove down a couple different articles, and the very large amount of time that it takes for us as humans to genotypically evolve and change,
yeah,
and then the speed at which the modern world is evolving and changing, and all these
yep,
different things that we're being exposed to now or not being exposed to.
uh huh.
Um, the Do you think that we're altering our phenotypic expressions in what might seem real time? Like, can you think of any examples off the top of your head where phenotypic expression is noticeably within one lifetime outpacing our genotypic evolution?
Specific examples, I mean, usually, because it exists on a spectrum in terms of influence, I would say that diet is the most intimate in terms of the
Hmm.
effects it has on our genes, because we're literally eating
Right.
food, like we're putting it inside
Hmm.
our bodies, right?
Yep.
Um, but other things that aren't as intimate but are still a stark deviation. I mean, we're talking about like climate controlled environments are one, actually.
Mhm.
We're talking about what we're doing right now,
Yeah.
talking to each other through the screen. I think, you know what? You know what?
Right.
You know what? I think this is a really good point. This is a really good example because now that I just brought this up, I was just talking to someone about this a few days ago. I don't think that we are evolved. Well, I know that we're not evolved, but especially like the way that we comprehend this thing mentally
Mhm.
to communicate with people online in the exact same way that we would communicate with them in person. We can't
Yeah.
see the person the same. We don't see the person the same way that we would if they were actually right in front of us. That's why
Mhm.
people are far more likely, and I don't use the words more likely lightly. Um, I think that people are far more likely. I think it's pretty obvious to be able to threaten someone online
Mhm. Mhm.
as opposed to face to face. Um, they are more likely to be sadistic towards the other person and wish harm upon them, even if they're not going, even if they're not actually threatening that they're going to do something to the other person.
Mhm.
I mean, look at social media comments. Look at them on X. Look at them
Oh,
on
yeah.
YouTube. Look at them on literally any social media platform, Facebook. You know,
Mhm.
you will see the distinction. You will think, and this gets to my ultimate point here. You will look at that and you'll immediately think, "Oh my gosh, like that's what people are like nowadays? Like that's really what we're," because our brains don't see the difference. They don't see that distinction yet. We can't distinguish between reality and
Yeah.
and online. And to be fair, there have been I don't even know where I lie on this regard. Like is it real or is it not real? Because I mean a real person wrote that comment. Like, but you'll see it in yourself. Like if you're really really conscious of yourself and your actions, you'll see that you are far more likely to respond in a certain way, like with negative emotion towards a comment that you see. If you see it on a YouTube, if you see it in comment form online,
Mhm.
as opposed to if the comment was made in person, and
Well,
it's like,
I I think that taps back into our very primal evolutionary fight or flight mechanism because you and I, two men standing face to face talking to each other, you'll find that men typically turn to the side. Very rarely do they stand there and talk face to
stand,
face.
yes, exactly, yeah,
So they turn sideways, and that's an ingrained thing to show that there is no threat. Um, and I think it's kind of the same thing, especially in the being a man in this world. Is there's always, no matter how small, there's always the potential for possible physical altercation, for
yep,
things to go down that path.
yep,
And yeah, there is a there talking through the screen or through the comment section, there is a certain level of a lack of recourse, uh, that you
mhm.
can type whatever you want, nobody's going to do anything to
Yeah, no, no, exactly, and I think that's an example of what you're referring to, because we have many of those examples. That's the one. That's the one that's most prominent in my mind. But I think that you're
you.
getting to a point. You're getting to that article that you sent me a while back now,
Mm-hmm.
and
Mm-hmm.
I actually reacted to that. It'll be coming out soon. So by the time that
Okay.
this video's out, it will have already been released.
Nice.
Um, but it was a really good article because it was showing how fast our environment has been changing as a result of our brains. Like
Right.
us having the ability to reason. Um, Compared to what any other species, like in terms of the rate at which any other species would be forced to adapt, like their genes
Mm-hmm.
would have to be forced to adapt. And I did have, so I didn't have a problem with the authors and like what they said. I don't have any problem with that. I was actually thinking aloud. I didn't really know where to lie on this, or where to arrive at, and put my flag down in,
Right.
I don't really know. But I was having initial problems with the idea that their primary notion in this article, talking about how fast we're evolving, is, have we made ourselves a species that is no longer sort of individual in terms of natural selection pressures, like positive and negative selection pressures,
Right.
individualistic in that respect, into a group, like bees, how they evolve as a group.
Right.
So they actually, you have to evolve with the group. You can't evolve
Right.
away from the group. You have to evolve with the group. So whatever happens to the group is going to redound necessarily to every single individual bee. Have we made ourselves that way because of the structures that we've formed in society, like governments, like
Mm-hmm.
composite school systems that are
Mm-hmm.
sort of, they're also in a way governmental. Department of Education in the United States, for example, has influence over that. Um,
Mm-hmm.
and all these other structures that we've made that are necessarily um, like even just Law and Order. Like
Yeah.
they I think they even mentioned Law and Order in there. We have built governments and overall societies like that force us to not be so individualistic, but they actually force us to be, sort of um, groups that evolve as groups,
Mm-hmm.
like
Yep.
bees do, and like ants do. And
Mm-hmm.
what I didn't necessarily have a problem with the notion. However, I actually debated. I said, how different is that in reality? Because if humans we're already social creatures. We evolved to be social creatures because our notion, our things that are evolutionarily ingrained in us, like you just said, men usually talk away from each other. Women
Mm-hmm.
are different. They usually talk
Mm-hmm.
directly to each other like that.
Right.
Um, that precedes governments and societies, which tells
Mm-hmm.
us that we were already evolving as social creatures before that.
Right.
So it's not to say that they're wrong. I mean, I'm someone that's not, in terms of my fields of expertise,
Yeah.
I would consider those biochemistry and statistics. It's not
Yeah.
evolutionary biology, at least yet, right?
Yeah.
Uh, and so I was exhibiting some humility, and I still am. I don't know. However, as I was reading, I was like, I question how different those really are in practice. Um, I mean, who like I don't know. I don't know, but it is a very, very important point to address, because that goes along with the entire notion that I've been promoting, which is
Mm-hmm.
we are evolving at a very fast pace. That includes diet. And diet seems to have the most influence over the negative heart health outcomes that we're seeing,
Right.
um, with respect to all the other interventions that we've introduced that are a stark deviation away from what we were doing, because of the intimacy of diet on our genes compared to all of the others. In terms of, like, if you're going to rank them on intimacy level,
Right.
do I think that blue light, for example, light exposure is going to have as much influence as eating a bunch of carbohydrates and fruit and honey and fiber all the
Mm-hmm.
time and deuterium all the time? No, I don't think that. And I mean, always in theory, I mean, I could be wrong about that, but I find that hard to believe. And I think that in practice, we're seeing that diet. That's why I focus primarily on diet.
I
It's not
mean,
to,
I think if you wanted to challenge somebody to try to find another variable outside of what we what we put in our mouth, um,
yeah,
I would challenge anybody to find something that has had as much of a drastic change on our physicality as food has in the last 50 or 60 years.
exactly. That's exactly what I'd say in response to that as well. Because it's like, it's not to say, and that's why you referenced that video. Modern life is an experiment. Because I've been thinking about this for
Hmm.
a long time. You can't really say, like, if you're gonna take my main position, my primary position, which is um we should be engaging behaviors that we are most genotypically evolved to withstand. I say that, like,
Hmm.
I've said that 1,000 times, right?
Right.
If you're going to take that to its logical extreme, we wouldn't have, we wouldn't have government, we wouldn't have technology, we wouldn't be able to make these videos, right? And and
We
and
wouldn't
we
have
would,
grocery stores.
exactly.
Yeah.
And yeah, exactly. And we, like, there wouldn't be like a typical, there wouldn't be a uniting culture. It would just be free for all,
Yeah.
and winner takes all. And so I thought about it and I went, well, if someone, yeah, so if someone wanted to take it to its logical extreme, they'd have a reason to do so. If that were actually, like, fundamentally true and there was no nuance behind that claim. And
Hmm.
so I realized, I was like, okay, well, there's nuance that I need to cover, because I don't want to be the person that doesn't cover that nuance. Because, I mean, it'd be kind of hypocritical, right? If I'm saying that and while also making a video
Here.
reacting to a bunch of people. Yeah, exactly. So
Yeah.
I thought about it and I was like, well, I obviously don't think that we should be like complete. I I'm not a complete I know there's ambiguity with regard to this term, so I'll say it and then I'll give my definition that I'm working with here. I don't think that we should be complete abolitionist anarchists where there's no government whatsoever. There's nothing at all, and we go back to how we were living like 50,000 years ago. I don't think that. We're way better off now as a species, and we're able to therefore make the world a better place with our ability to reason. Like technology has done a lot for the world. It's done a lot to the world as well, and those are things that we need to remediate, and we're continuing to remediate them and or figure out how to do so. Because I mean, AI is the new thing now that we're going to have to contend with. We've been contending with that in that respect. But I don't think, I'm not one of those people that's extremely, we should just revert back to 10,000 years ago, life 10,000 years ago. Like things were really bad 10,000 years ago. You know what I mean? But then if I'm going to say that, well, then I have to make a video discussing like what my actual positions are, discussing all the nuance. And before I make a video about it, I have to write a paper about it. Like I have to write my thoughts down in a comprehensive way. And so I did it, and it was, modern life is an experiment. Like, okay, what is the balance that we must have between maintaining what we're evolved to withstand so as to, not deviate too strongly away from the species, so as to preserve the well-being of the species, while also progressing by using our minds that are the main thing that distinguishes us from every other species, like our ability to innovate and make this computer that's in front of me, right? So that we can actually make the world a better place, because everything, I don't like the idea of abolishing these tools because they can have a bad impact. That philosophy will get us nowhere, because it'll make the world a worse place, because a tool is not anything in and of itself. It's something that can be used for good or it can be used for bad, unless the tool literally has no ability to be used for good, in which case, okay, fine. Then you can have an argument as to whether or not it's really used as it's really a tool in the first place. But you get my point, and I think that I had to discuss that nuance there and cover what is that balance point. And I said in the video, we don't really know what the balance point is. We're trying to find that as a society, as a functional society, while we try and establish the ultimate form of functional order. The ultimate truth.
I think as much as there are positive and negative selection pressures when it comes to our genes and our phenotypical expression, I think the same thought process could be applied to positive and negative selection pressures when it comes to a societal evolution or the evolution of societal construct.
And that's exactly what the article covers. Like it's the same sort of thing. And what I said in the video regarding that article was, the only problem that I had with the authors, if I'm remembering correctly, and I want to make sure I get this right, was that they were seeming to act as if culture. So they called it, they distinguished between cultural evolution and biological evolution. And I said, well, those are that was my only problem, was drawing that distinction as if those are two separate things. Because if culture is a consequence of our brains coming together to construct things, well, our brains are part of our genome. They're part of our genetics. They are actually biological. So they're just a function. They're just a redounding effect of our biology. So really, it all still is biological evolution. That was my only problem. But throughout the whole article, they were just making that distinction as if there was a distinction between the two. And I was like, well, I think that one is just a function of the other. It's not that they're two separate things. Because, and I get what they were saying, though, because I already covered what they were saying. Like the whole phenomenon of cultural evolution is the idea that we've actually progressed biologically so much in terms of our ability to reason that we have therefore formed a culture that has almost made us less independently evolutionary, but instead a group evolutionary force. Like, you know what I mean?
You're right.
So, but I think that's all just a function of the overall progression of the universe, really. If you're going to believe that time is some linear function, then you're going to get into quantum physics. So we won't go there. We won't go there.
We're not going to go there tonight.
But I think that's. I've thought about this for a long time, and that's the great thing about making this material that I make publicly is it forces me to think about things harder than I did before I started releasing the videos. Like,
Right.
I never thought about that until I heard people saying, oh, well, back in the day, we used to, um, I don't know, we used to eat rotten animals. And it's like, well,
Yep.
yeah, but then we stopped eating rotten animals. We started cooking our meat and stuff. And it was like, yeah, but also, let's say, what's a good argument? What's a really good argument here? Because I mean, most of the time, when it comes to diet related things, I think that we should be emulating a lot of what we did in the past, which is like my main that's my main
Yep.
position. But I'm
Mhm.
I'm mainly thinking about like, oh wait, well, yeah. So someone will say, oh well, I mean, we went through harsh winters like historically, so we should do the exact same
Mhm.
we should like suffer through the extreme cold. And I go, well,
Right.
hold on a minute, because there's a lot of people that like died from that. And it's like, well, I mean, don't you say that didn't we evolve to genotypically withstand cold temperatures then if we evolved during the Pleistocene epoch primarily? And it's like, I had to contend with it because at first I was like, well, that's different than diet. But then I thought to myself, because I'm always questioning myself, I'm criticizing myself harder than I criticize people on my videos. And that should
Right.
say something. And I saw
Yep.
it, but I was like, well, okay, so then what's the difference? I had to ask myself, well, what's the difference between the two? And that's what
Mhm.
culminated into that paper. That's what culminated into that video.
Yeah, it's it's how extreme do you want to get? Like, how far back to basics do you want to get? I mean, if some people want to give up their air conditioning in the summer, or if they want to give up their central heating in the winter, like, okay, do your thing. But if you think that since the ice ages that we as the human species are still growing as much body hair as we used to, or
Yep.
we have, or I mean, even all the way down to the viscosity and composition of our blood or the thickness of our vasculature walls. I mean,
Mhm.
there are things you don't know and you can't account for.
Yep. No, I completely agree. And so I think that everyone should check out that video of mine. I reference it a lot. And it's a very efficient way of me getting the point across in more detail because I
Uh,
spent a lot more time on that
The
than
modern
I
life
am right now.
video,
Yeah.
yeah, and um it's not that long of a watch either. I was I was kind of surprised by that. Like you're pretty good about putting out, hour and a half reaction videos, which I really enjoy. But
Yeah.
um but the modern life is an experiment video. That was it was very very thought provoking in a outside the box kind of
Mhm.
way.
Well, good. Yeah. That's what I like to do.
Right. As far as I wanted to talk to you because you referenced this a few times in your videos. The what is what is normal or what is healthy according to who and on the basis of what is one of your
Right.
favorite lines that I hear. Um, so if we can't trust the quote unquote normative range when we go to the doctor, and there's always like this sliding scale based on the population in that region. Um, how do you think a single person that wants to dive into taking care of their health, how do you think they can kind of hit the reset button or what measures they can take to establish a baseline with their health and then start taking steps towards uh, a progression to optimization?
Okay, so you're asking, if you can't trust those normative ranges, then how does someone know that they're ready to engage in a different, dietary behavior? What's their what is their fresh baseline that they should
Yeah,
aim towards?
what could we do for like a metabolic reset or maybe
Okay.
go on a 7-day fast or something? Like where's the reset button?
Yeah, I mean, I think it's very individual depending on who you are, as are most things. I've seen that some people, yes, as you mentioned, will typically embark upon a fast. However, the first thing that comes to my mind is if someone needs a metabolic reset, they're typically not going to be able to fast too well,
Right.
because they're people that eat all the time and they eat a lot of glucose all the time. It's not just fat and protein; it's a lot of glucose, um, and carbohydrates in general. Um, I think that there's also something else that people have done, which is called metabolic priming, where instead of
Oh,
fasting, it's the exact opposite, which is
right.
eating a ton of food for 7 days and then going on like a 5 day fast or something like that.
Mm,
So it is fasting, but there's a priming period beforehand. That's why it's called priming. You're priming yourself up for the
right.
fast. And it's the idea behind that is to get you really nutritionally replete and ready to it's a way of getting you nutritionally replete while also making you completely sick of the food that you're actually eating so that you're more likely to stick to the fast because you're like, I don't want to eat anymore. I'm done. I'm done.
Right.
You know?
Yeah.
And do I think that that can work? I mean, perhaps I'm not someone that coaches clients, so I don't know I don't know enough about what protocols will work and which ones won't. I've heard of a lot of them, and I've heard a lot of anecdotes about people that say that priming is something that has really helped them whenever they're beginning a carnivore diet.
Mhm.
But again, it's going to be highly individual. There's also the typical way that I approach it, which is okay, you're eating a certain way right now. I did this with my fiance years ago. I was like, okay, so you're eating this certain way. Your body is going to be used to doing this thing. So what you want to do is you just want to instead of doing exactly a hard reset, it's just
Mhm.
really tailoring. It's manipulating the transition window, whether
Right.
you expand it or whether you shorten it. Typically, I wouldn't shorten it below 6 to 8 weeks, but longer than
Mhm.
8 weeks, maybe. I mean, it just depends on what's going on. I think it's
Right.
all going to be experimental because every single person is very, very, very different. I mean, it always astonishes me how these two things can be true at once. One of those things being we are basically we're 99.99% genetically identical, but we're
Right.
also so insanely different that the way that you're going to phenotypically adapt to a diet that is a transgression away from what you're genotypically evolved to withstand is going to be so variable depending on who you are. It's amazing.
Right.
Um, so I do think that the primary thing that we should be doing is instead of exactly a metabolic reset, you're sort of doing a metabolic reset, a gradual one, whenever you're slowly transitioning away from your previous diet to the new one in a way.
Right.
I mean, I think that you can think of it that way. But in terms of like what are considered official metabolic resets, the only two that I'm really aware of is yes, you're doing like a water fast. You just completely
Mhm.
quit eating. You're like, well, like the day before you eat, a few meals or one big meal, whatever it may be, and of the normal food that you eat, and then you just go on a fast. Um, whether it be a water fast, whether it be a dry fast, typically the water fasts, but or it's you add in another layer on top of that, which is the priming thing, which is you eat a
Mhm.
bunch and then you fast, and you're eating a bunch of meat and fat, like all
Right.
that stuff. Do I think that you should be doing that? Do I think that you should be doing that with carnivore food if you're not a carnivore yet? I'm not really certain about that because typically priming happens over the course of like I think maybe 7 days. I could be wrong. I could be completely wrong about that, but you can imagine what that could do to your gut microbiome. There's people that have done that before. They go carnivore the day after, like just okay, tomorrow I'm going carnivore, and 3 days later they're done.
Oh, yeah.
So
Yeah.
I don't think that's a good idea. If you're gonna do that priming protocol before a fast, you better be eating the foods that you typically eat,
Yeah.
even if it's Twinkies, man. Like, go okay, fine, man. If you're gonna do this and fast afterwards, like go and you're gonna stick to not eating this food afterwards, like go ahead. But of course, yeah, I wouldn't really do the whole priming thing in that regard. I think priming is more so a thing that you do when you're already carnivore and you're trying to get some significant fat loss happening. If you're in a stall or something like that, you're already adapted to
Right.
carnivore. You prime with a bunch of carnivorous foods and then you fast for days. I would
Right.
not actually prime with things like Twinkies and ding dongs and potato chips. So
Right. Yeah.
um, just while telling yourself, oh, but at least I'm fasting afterwards. Like, yeah, yeah, no. I would focus primarily on that transition period and manipulating the transition period according to how they seem to be adapting to the diet. I think that's the best way of going about it. I really do.
Okay.
Most of the things that I believe in are typically like I think they're a lot my for the sophistication that is involved in what I say in my videos. I think that it might take people by surprise at how simplistic my conclusions are.
Yeah.
Um, it reminds me of that little like meme or whatever. It's like a bell curve, like a normal distribution curve for IQ, and
Yep.
it'll show like the dumb person on the end, and it shows a conclusion that they arrive at, like a position that they have, and then it shows the middle of the IQ, and it's like, oh well, actually, you should be doing this. And then on the very other end,
Yep.
it has the same conclusion as the stupid person because they realize, oh wait, well actually, it's just really it's that simple. So
It's
I
just
don't.
really that simple.
Yeah, yeah, and I'm not saying that that's the case for everything, but I find myself saying the same thing oftentimes. Like like
Yeah.
the same thing happened. Like I believed that thing before I went carnivore, and then I didn't because I was like, oh, there's a lot of nuance here. And then after I
Mhm.
discovered even more nuance, like all the nuance, I was like, Occam's razor. Okay,
Yep.
Occam's razor applies here. So, so
Yeah.
yeah.
Does this is something interesting that I ran across the other day. Um, Cutting back on salt when people are told to cut down on their salt.
Uh-huh.
Um, does cutting back on salt to a certain degree cause the body to respond by secreting insulin to encourage the preservation and storage of salt currently in the system, and ultimately result in higher blood pressure and an increased potential to develop insulin resistance?
Okay, that's actually a good point to talk about because I read about this years ago because this has to do with like hormones like aldosterone and all that stuff. Whenever you restrict,
Okay.
if your sodium intake is really really low, there's a chance, depending on what else you're doing as well, that you could develop problems with, well, I mean, the same problems that are always associated with low salt intake. I mean, you're talking about
Right.
electrolyte disturbance problems, and your
Hmm.
heart palpitations can happen, and
Yep.
all
Yep.
that stuff. Um, what I've seen is that it's been a while since I've actually read this, so I should probably just go back and look at what the conclusion was. Just for clarification, though, this person that wrote this was Dr. James DeNicola Antonio. So in terms of the
Okay.
quality of it, I'm not certain. Um,
Hmm.
just because I'm not a fan of what he says about acid base balance and all that stuff, and the video he has made about me before, that doesn't mean that he
Yep.
was wrong about this.
You're right.
But because he wrote that Salt Fix book, the Salt Fix, and
Hmm.
I think he mentioned something like that in there. What I can say about salt is when it comes to salt sensitive hypertension, because we've been told for a long time that salt,
Hmm.
causes high blood pressure. What can end up happening is that if you have a large, well, a high sodium intake
Yep.
alongside carbohydrate intake,
Yeah.
um, the insulin that is raised will help to maintain sodium, which gets to the kind of the root of your question, which is if you cut
Hmm.
down sodium too much, can you actually will the body respond in a way that raises insulin to
Yeah.
preserve as much sodium as possible, which can lead to, insulin regulation issues or even like, well, fat storage issues, for example. So whatever you're
Yep.
actually
Hmm.
eating, may more of it may be used to be stored instead of used for tapping into it for energy and energy
Right.
creation purposes and all that stuff. I would say potentially. I haven't looked too much into literature about that. You know what? I'll actually write it down because I'm always curious to look into this myself. Look into the actual statistics regarding it and the mechanisms there. I mean, we already established a mechanism for hypothesis generation. So we've already like that you've generated a hypothesis, and then the next thing to do is actually see if it's been tested
Right.
under adequate. Um, I would say adequate control, but adequate is complete control theoretically. Um,
I was waiting for it. I was like, "There's no way he's about to say control. There's
Yeah,
no
yeah,
way."
yeah. I would say control. I mean, like sufficient control for a strong enough signal, but then you would have to look at repeatability and
Right.
reproducibility of the results. So I can actually look into that here, actually. Low salt and insulin. What I also will say while I'm writing it down is that um, I don't know if you heard me say this before,
Mhm.
but I now have a friend, and once I actually made this story public, I've gotten a bunch of people in my comments saying that they had the exact same thing happen to them and they fixed their issues the same way. They were
Okay.
dealing with the classic electrolyte imbalances that can happen on carnivore, like leg cramps, really bad leg cramps, heart
Okay. Yeah.
palpitations, headaches, and all that stuff. And
Mhm.
the thing that helped them was not increasing their salt intake. It wasn't, increasing their water intake or anything like that.
Right.
It was cutting salt out, and that was something that I was like, "What? How does that even make any sense?" And then I thought about it for like 2 seconds, and I went, "Oh, I feel like an idiot for not even realizing what I think is going on with a lot of people is when you're talking about leg cramps, you're not really talking about sodium imbalances. You're talking about magnesium.
Mhm.
You're talking about magnesium because magnesium plays a role with calcium balance. They play a role in muscle energetics, I suppose, but not really energetics, but they play a role in muscle contractions, the anatomy of muscles. You need
Right.
calcium ions, Ca2 plus, to bind to myosin binding sites on actin filaments for a muscle contraction to even occur. If you don't have that calcium there, the muscle contraction won't happen. But if you have too much calcium there, your muscles are super tight all the time. Like
Right.
that can happen a lot, and so their ability to relax. I mean, they can still relax, of course, because in order for a muscle contraction to even to relax, you actually require ATP. So as long as your muscle energetic systems are working properly, you'll be able to relax the muscle, but perhaps not completely. You'll get cramping, you get all these problems because magnesium plays a role in relaxing muscles. Um,
Right.
it's Mg2 plus. I mean, they're very similar in structure. They can actually bind onto those. They compete with calcium, and they can relax your
Mhm.
muscles. So that's the mechanism there. And I was like, okay, well, what happens whenever you have electrolyte imbalances because you're eating too much salt? Like, can't that happen? Because
Yeah.
if you eat a bunch of salt, what's that going to do? Okay, it's going to make you thirsty. You're going to drink
Mhm.
water. Okay, well, what are you not changing the value of? What still remains low? Magnesium, uh,
Mhm.
calcium itself, actually. Not in my case because I have calcium in my water, but other people don't. Like,
Right.
okay, calcium. What else do they got? Potassium's low,
Yep.
right? So if you're increasing salt, you're talking about two electrolytes, sodium and chloride. You are not
Mhm.
talking about, and also you're increasing your water. So you're just further diluting the one
Diluting.
electrolyte that's probably causing you problems, which is
Yeah.
magnesium. So what happens whenever you cut out all your salt, or at least like strictly limit it? Well, you lower consequently your
And
water intake as
mhm.
well, and then you get more on a balanced level. Because a lot of people think that the
Mhm.
balance needs to happen in the upward direction. Like you need to bump magnesium up, you need to bump potassium up, you need to bump,
Right.
calcium up. What if you just grab your water and your salt intake down? What if you bring those down
Yep.
instead?
Yep.
And I had so many people tell me they're like, "Yeah, I had those problems until I cut out salt. I thought I was salting to taste, but in fact, I really I wasn't. I was eating enough salt to the point where I was thirsty for like 2 liters of water. I was like drinking 2 liters of water a day. I'm like, wow, okay, yeah, it's a lot of water. Of course, you had cramps.
Right.
But yeah, you have two options. You either increase your magnesium and take a magnesium supplement or something, and
Mhm.
calcium and potassium, or you lower the water and salt. And I've
Yeah.
noticed it makes complete sense to me now why people like Anthony Chafee. Last I checked, he said that he's not eating salt. Like he's just not eating salt. And the other thing that I noticed was that my friend noticed was that when he cut out salt, his meat he noticed that his meat tasted better than he has ever tasted his meat. Like he's ever had his meat taste before.
Right.
He was like, I'm tasting flavors that I didn't even know existed when I had salt on my food. He said he's never going back.
Yep.
So I don't use that much salt in my food. I'm very, very low
Right.
salt, really.
Mhm.
Um, I'm not no salt though. I've tried like getting lower and lower on salt, and I'm sure that what would happen is if I did it for like 2 or 3 days, I would get used to it, of course.
Yeah.
I'm just not having any problems with having salt, so I'm just not going to cut it out.
Right.
And I don't think there's any problems associated with salt intake. It's a pretty innocuous molecule. But I did want to touch on that if you're going to be talking about lower salt and higher insulin, because as far as I know, the people that are cutting their salt out super low
Mhm.
to having absolutely no salt, they're not really having any problems with insulin regulation. But of course, appeal to ignorance fallacy. We got to be careful with that. Just because we don't have any evidence of it doesn't mean it's not happening.
Right. Yeah.
but I can say that those people are doing better than they ever have been
Hmm.
on a carnivore diet when they cut salt out. So do I think it's an extreme problem? Maybe depending on who you are,
Yeah.
depending on what you're eating. Depending on what you're eating, perhaps, yeah, sure. I think that
I
that's something
mean,
that I need to look into.
I mean, if Anthony Shafee cut out salt and then his food tasted his steaks or whatever cut he was eating began to taste better. I mean, when we taste something that's sour or spicy or bitter, that's all these mechanisms working, saying no.
Yeah,
So
yeah.
by him cutting out salt and then his meat taste. I mean, he's been carnivore for a long
Hmm.
and he's one of the strictest carnivores, right there alongside Sean Baker that
Yep.
I've ever seen.
Yeah,
Um,
yeah, yeah.
so has has he just been in this 5 year, 10 year transition, you know, towards this super strict lion diet, I guess you could say, that is meat and water? That he can dive into that. I know I would have a wild adjustment. Like, it would be miserable for me if I cut out all salt in my diet overnight.
Yeah. Yeah, I don't know. I mean, it's a very interesting phenomenon, and the one word that just keeps coming to mind is interesting and fascinating, because I can tell you that if you had told me that, eating no salt was something that was even able to be a phenomenon that would result in, or at least allow you to maintain a healthy physique and a healthy
Hmm.
affect in the world and presentation,
Hmm.
I don't think, I don't know if I would have looked at you like you were crazy, but I think I would have been like, that I don't really know about that. I think you need some salt in your diet. But then I thought more about it, and I was like, it's not like we didn't seek salt out in history. We
Hmm.
did, absolutely. There's other animals that do that all the time. They find salt licks and all that stuff.
Hmm.
Um, However, I kept thinking to myself, you know, we didn't get salt all the time, though. It's not like ubiquitous across the
Right.
environment. So where else were we getting our sodium from? Well, we did have some blood of animals. However,
Hmm.
if you're also going to say that we cooked our meat, well, you're actually cooking a lot of blood off of it, right? Like, you're not. It's not going to be something that is as teeming with blood as if you just ripped the animal open and then just ate its flesh right there, right then and there. So I
Hmm.
was like, I wonder if there is some truth to, like, having low sodium intake, um, in terms of, because low sodium intake, when we talk about low versus high, you're really just talking about what amount is needed, and what is the amount that we're evolved to have,
Yeah.
mostly. And do I think that we evolved to have a ton of salt every single day? Yeah, maybe not. So that's why I've usually said salt to taste. But what if our tastes have changed, or,
Hmm.
are different, and are a deviation away from what we should be expressing genetically, because we were raised with a bunch of salt or something like that? Like,
Right.
who's to say? Like, what if that wouldn't have happened had we not have been provided with a bunch of salt during our childhood? What if our tastes would have just naturally been like, oh well, because when we talk about salt to taste, I mean, who's to say that your tastes are omniscient? Like, they should know, they know exactly what you should be having, because I
To
mean,
whose taste?
yeah,
Yeah.
like, okay, what about people that have a taste for carbohydrates or something? Well, you would say,
Yeah.
no, that's just a craving. That's just a craving that you should ignore, because you're it's not required, and it's like an addiction. It's like if you're craving a cigarette or something,
Right.
you know? It's not the same thing. Well, then who's to say that you wouldn't say that for salt as well?
Yeah.
I've usually said salt to taste, and I still do it, because your propensity for overeating on salt is much, much, much lower than overeating on carbohydrates. Usually, you'll know if you have too much salt in your food, you can't even eat it. So And that's not
Yeah.
really the same thing with carbohydrates as much. Like if there's a lot of carbohydrates in there, typically what I'll do is go, wow, that is really sweet. Let me go in for
Yeah.
another bite. Like that's not,
Right.
yeah, that it's not the same thing with salt, which is why I've been comfortable enough to still say salt to taste. Because sometimes people, when they hear salt to taste, it's no salt at all.
Yep.
So but yeah, so low salt and insulin. Um, I'll look into that because I don't have a clear answer on that. That'll be
Yeah.
something that I can research on my own.
Yeah. I would be interested to hear what you come back with. Um, uh, Hanging out on insulin resistance. There a relation between visceral fat and its contribution to system-wide inflammation and insulin resistance?
Contribution, yes, I think that it can play a role in a positive feedback loop. I'll explain why. Visceral fat, so fat in the organs like the liver, and even the stomach, associated with things like alcoholism and stuff like that.
Mhm.
Um, you gotta think about why that fat is even building up there in the first place. And a lot of times, it seems to me that it is a slowing of the rate at which the mitochondria in those cells are functioning,
Okay.
which oftentimes is the result of inflammation because you've got a poor redox potential, poor NAD to NADH ratio, um,
Mhm.
and that is almost invariably due to a slowed rate of mitochondrial function because you've damaged them in some way continuously. And
Right.
so what can happen is I mean, your liver is an extremely important site for metabolism. Uh, we'll be covering that. We've already touched on it a bit in the biochemistry course, but we'll
Yep.
be
Mhm.
covering that in far more depth when we talk about. I mean, just think about it. Think about it. You've got the liver is the main site for glucose production, ketone
Mhm.
production, fatty acid oxidation,
Right.
glycogenolysis. There's glycogen storage there, so it performs glycogenolysis and glycogenesis. It also performs glycolysis. It also performs fructolysis, so the breakdown of fructose before it even
Yep.
reaches your bloodstream. I mean, there's so many things. There's so many things that it is the site of. But oh, I'm sorry, fatty acid synthesis, so it creates fats.
Yep.
Triglyceride synthesis, so it creates triglycerides as well. Um, it's also the main site for oxidative deamination of amino
Mhm.
acids. So
Yep.
it is a powerhouse, the liver. Um, and so when it comes to, if you can imagine what happens if you slow the rate at which the liver functions. Could you
Yep.
perhaps get a buildup of fat there because a slowed rate of beta oxidation can occur, or a
Mhm.
buildup of here? There's many different variables here because you can have that happening as a contributory factor for fat buildup there, but you could also have um, if you're talking about slowing the rate at which the mitochondria function, what typically does that? Well, it's things that damage the body like glucose and
Yep.
fructose. And
Yep.
so if you damage the cells that way, um, then you could have an increased, if you're damaging the cells that way, that could explain the inflammation resulting there. But also, if you're doing it with glucose and fructose and all that, you're also going to
Mhm.
get a buildup you're going to give it more substrate to work with and more hormonal responses that are conducive for the buildup of fat.
Yep.
Like itself, like even as its own factor and variable, especially, fructose. I mean, fructose, if you didn't know, and I think, no, you know what? I covered this recently. No, the video will be out by the time this video is out, but the video isn't out at the time of recording. I was looking into allulose, the sugar
Okay.
allulose.
Yep.
And I'm not going to get all the way into that, but one of the things that we covered in the video was that fructose, we covered this in the glycolysis lesson of the course. Fructose is
Mhm.
like 45 times more glycating of a substrate per
Yeah.
mole, like in
Oh,
aqueous
okay.
solutions
Yeah.
in physiological temperatures than glucose. And but there's nuance there, and I covered that in the course, but I covered it more so in this video. In the course, I said, or in the lesson, I said, oh well. To be fair, we don't want to be reductionist. We don't want to be like hypocritical here. As much as that's true, fructose is rapidly metabolized at the liver, like more than glucose is in the first bypass. So whenever you absorb sugars, that goes to the liver first, and then it goes into the bloodstream. That enters the
Mhm.
portal vein and then goes to the liver and all that stuff. So I wanted to explain that Well, the rate at which the blunting of the introduction of sugar, so the introduction of glucose, that rate that the liver will blunt a glucose spike, is not the same degree that it will blunt fructose introduction into the bloodstream. Fructose is blunted heavily. That's why fructose is metabolized so fast at the level of the liver, that the pathway is so much faster. And so when you're talking about fructose, that is almost immediately converted into fat at the level of the liver, because so you're actually, even then you're contributing to fatty liver disease and all that stuff, non-alcoholic fatty liver disease. I think more so with fructose consumption than you are with glucose consumption.
Right.
And so yeah. So to get more so to your point, there's many factors that could be contributing that would cause this visceral fat to be involved in insulin resistance, because all those things are associated with insulin resistance, the phenomenon of such. Could fatty liver disease actually be contributing towards it, like as a sort of catch-22 situation? I do believe so, because at the end of the day, if you've got, the insulin resistance as a phenomenon is where you've got a level of glucose, or you've got a level of insulin in the blood that may be commensurate with the amount of glucose in the blood, but that amount is not enough to get the glucose down. You need more and more and more insulin. Like you're becoming more insulin resistant.
Yeah.
But where does that glucose tend to go if it can't go into muscle cells and can't go into fat cells? Well, it typically goes to the liver. But then if you've got a bunch of fat in the liver, all these cells, these fat cells, or these liver cells, to go back to the original point, if you've got a bunch of fat in the liver has a maximum hypertrophy, just like every other cell. Like it can reach a maximum size until it can't reach that size anymore. So if it can't store more fat there, well, then the glucose can't be used to create fat, because it's not even going to be able to store it there. It can't store it in your fat cells because you've reached maximum hypertrophy and hyperplasia of your fat cells. It can't store it in your muscle cells because the same thing has happened to your muscle cells. So you've got a bunch of fat that's just plugging everything up. This is actually the vegan argument. Oh, well, the fat's the problem because, look at all that fat blocking the glucose from entering the cell. It's like, yes, but how did you generate all that fat? Okay, because you think you're going to do that by just eating fat? Sorry, that's not happening. You're going to be, it's if you're eating fat and carbohydrates together. I'm not even convinced that you're going to reach that level by just eating carbohydrates. You'd have to eat all, like, fat, protein, and carbohydrates together. Like, boom, throw them all in with each other. But so that's one thing. So you can't even store fat in there. So that would contribute to insulin resistance that way. But also, if you slow the rate at which the liver can function as well on top of that, well, then even if it could absorb and store onto more fat, the rate at which it's actually going to be able to do that is going to be slower. So the rate at which the glucose will be cleared from the bloodstream through that pathway is going to be inhibited as well. And this is when you get a phenomenon whereby you get basically like chronic diabetes. Like you got full on diabetes. So you got full on diabetes, and then you get that's type 2 diabetes, and it trends towards type 1 because it's going to damage your beta cells of your pancreas because you've got so much glucose there. And, well, it's going to be damaging the cells of the body, and that would include cells of the exteriors of the organs, like transporters and all that stuff, the proteins themselves, because that's what glucose does. It glycates proteins. And like a protein would be things like GLUT2 transporters. Transporters are typically made up of proteins. You've got like millions of proteins sometimes on the outsides of cells, and they all introduce, they all have influences over, they all allow glucose to bind onto something. Let's just put it that way. So yes, I do think that visceral fat can be a problem in that regard. And in fact, I think I've talked about this, not too recently, but a little while back, whenever I reacted to those two orthopedic surgeons, along with the physician with them, that wanted to talk about insulin resistance with us like we were children, like with Sesame Street style presentation. So yeah, it's not like she didn't have points that she was making that were correct. Like, yes, fat can plug up the system and all that, and then you can't get glucose in. But guess what? The problem is not the insulin resistance. That's not the root problem. You can't say that that's the problem, because then you're justifying the creation of a drug that targets insulin resistance, like without considering the problem that undergirds the insulin resistance, which is, well, you ate a mixed meal and not just a mixed meal, but a mixed meal full of things that also induce inflammation, even outside of the context of the carbohydrates, like all the plant toxins, all the other industrial waste products, and Twinkies and whatever else you're eating. Like it's just the trans fats, you know.
I mean that's another fun uh that's another fun discussion about today's modern life as an experiment is everybody everybody's comfortable with what they know, and we and we are creatures of habit, and whether your habits are good or bad, if if I can create a pharmaceutical to fix your symptoms so you can just keep on with your current lifestyle and not require any effort on your part besides going to the bathroom in the morning and popping this pill before you brush your teeth.
Mm-hmm.
There, for me as the manufacturer, there's way more money in that than there
Yep.
is coaching people on how to break bad habits or change their lifestyle.
Yep. Yeah. I have an interesting take regarding the pharmaceutical industry in that regard because I've actually said, like, because I'm not an anti-business person, uh,
Right.
and I've thought to myself, I've been like, the pharmaceutical industry, it's true that they profit off of sickness, like, and
They do.
it's a big problem. It's a big problem. They profit off of sickness. However, the question then becomes, should you penalize them for sorry, no, that's not a good way of putting it. You also have to realize simultaneously, though, that the reason that their drugs are so effective is because they or rather effective in the not in mitigating side effects, but like they have it. There's a competition to create drugs that sort of will keep you on them, so there's not an incentive to cure
Hmm.
the disease.
Yeah.
But there is an incentive for those people to still be alive because if they're completely dead, then they also can't profit off of it.
There's no money.
So
Yeah.
exactly. And so what I've thought to myself is I've been like, okay, so in a way they do good and also they do bad, like because
Hmm.
they do bad in the fact that they're profiting off of your sickness, but they're also doing good because they're keeping you alive. And
Yeah.
obviously, that's also a good thing. So I've thought to myself, I've been like, what is the alternative? Do we abolish the pharmaceutical industry? Because if we did that, then all these other things that actually are very beneficial, like these surgeries, the innovation regarding certain technology that we use to diagnose diseases, and
Hmm.
to be able to perform, really, really intricate, convoluted surgeries and all that stuff that we've created as a result of this incentive structure from this business. Those would also fall. So it's like, what is the alternative? And I thought to myself, I went, okay, well, the alternative is what we're doing right now, which is trying to get people away from the system because that's basically the free market system. Like that's how
Hmm.
things work. You get people to not be so dependent on them while
Right.
also recognizing the good that they do in fact do. But
Hmm.
it's a balancing act. I think that it's almost like along with the good is going to come some necessary bad from that system. Like it's a really weird system. Because I almost have there are certain workers that I've witnessed online that work for these industries that I see them, and they're the innovators, and they themselves are like really passionate about getting a drug that works. Like they really are. And I
Right.
almost feel bad for them because I'm like, man, I mean, if only you would actually, if there were no incentive structure
Yeah.
to make that drug, then would the world get better or would it get worse? It depends on how you look at it, actually. I think that it would actually, I don't know. I think the best thing for me to do is to think about it further to be able to articulate my thoughts more on this because this sort of transgresses from the health into a little bit of the political, and I don't really get into the political too much, but it's like the reason that they're having that passion to make this drug to help to at least in their minds help people, and in a way, like we said, they're helping people 50%, and also they're also doing them a disservice 50%. Like it's both.
Hmm.
It comes in a full package, is because there is that incentive structure there. So if you
Yeah.
remove that incentive structure, they wouldn't compete to even make these. They wouldn't be innovators. And
Right.
so I think that we have to be very careful with recognizing that they don't only do bad, because if you think that they only do bad, then of course your philosophy is then we must remove the incentive structure entirely. And then you got to be careful with that, though, because if you do, then the other 50% that they do that's good would also go away.
Hmm.
So
Yeah.
it's just a matter of being careful with it. But I think that the solution is what we're doing right now, which is, you know, um, making people aware that they don't, in order to fix the problems, it's not merely a matter of, not even simply merely a matter of, but it's not, usually it's not a matter at all of adding things in. So drugs, things like that.
Right.
It's
Right.
subtracting things from your
Hmm.
behaviors, and
Yeah.
getting things out of the diet, and out of your life that are causing problems that your body doesn't really know how to withstand too well, um, evolutionarily, genetically. So
Right.
yeah.
Um, yeah, it's funny to see how many. I mean, when you think about it, you look at the average person's bathroom counter with facial cleansers or washes, or and just look at the back and between three different products. Just count up how many, when we're talking about simplification and removal of these things. They how many chemicals do you put on your skin in one
Oh yeah.
single morning?
Yep. Yep. The like the phthalates and the parabens and all that stuff
Oh
from your
yeah.
shampoo and body wash and stuff like
Yeah,
that.
you jump into the shower, you do your body wash, and then you pick up your facial cleanser and you scrub your face with that,
Oh
and then
yeah. Yeah.
and then you're gonna get out, and if you put anything else on your face, maybe a moisturizer, maybe an anti-aging cream, maybe it's just the amount of stuff that we subject our our body to, which I think is pretty impressive. But I think it speaks volumes to how adaptive and resilient the human body is when it comes to all
Yes.
these different synthetics that we slam it with.
That's something that I've actually been saying, um, in my videos in the past, and still to this day. It's like we should actually recognize how amazing it is that we can, if needed, use plants and carbohydrates for energy. Like, and all these
Right?
things to
Yes.
adapt to all these. Like, it's amazing. It's actually a good thing. It's just the
Yeah.
way that, we abuse it now without realizing it. We abuse that
Yeah.
ability. um,
Yeah.
and we're making it to where we're actually losing our ability to to use fat and to use fat for energy, because then you try and go to a different diet that uses, that's only filled with fat, only contains fat, only composed of fat and protein, and you can't.
Right.
You're like, oh, keto flu kind of thing, So
Yep.
we're abusing it, because in reality, it's a good trait to have. It's good that when we, if we have no other choice but to do those things, we have the ability to live through it.
Hmm.
And I think that we should appreciate that, instead of, bashing plants entirely,
Right.
because I think that, it's important to be able to understand how to grow plants, how to cultivate them, and make them as non-toxic as possible in times
Yeah.
of need. You know,
Yeah.
um, in case you can't get your hand, you can't acquire meat or something like that. Because I see a lot of people, it's like they make it their ideology. It's plant hatred, as opposed to just being just living intentionally and saying, "Oh, plants really just aren't the best for us. We're not really evolved to consume them genetically and all that stuff." It's it's like they make it their personality to hate plants.
Yeah.
Like, and it's
Right.
like, okay, I don't know if we should like make it like that. It's just, appreciate the world for what it is, instead of making, if plants are part of nature, then they have a purpose. And so to hate
Hmm.
plants entirely, I just think it's a step too far, if that makes sense.
It's a lot. I mean, I need I love plants. I need food to feed my food.
Yes, yes.
It's
Yeah.
um yeah, I mean, there's going to be purists on both sides of the spectrum, right?
Yep.
There's going to be people that are completely anti eat anything with the face. Like, I hate the unethical murder of animals in any way, shape, or form. And it's like, easy, okay? Like, I have no problem gardening. I do believe, me personally, I believe that there is a medicinal purpose
Mhm.
for plants, but
Yeah.
in different scenarios. Um, I mean, you can. My mom, back east, she says you will brush up against one leaf and it will create a rash, and then two bushes over you can grab another leaf and crush it up and rub it on there and the rash goes away.
Yeah.
So
Yeah.
it's and she's diving into the apothecary and the herbology and all of those. So yeah, I think that the purists are just a little more extreme than necessary.
Yeah. I mean, they transgress towards nature hatred in a way. And it's like,
Yeah.
that's not the goal. That's not the goal. It's to live intentionally, not to hate nature or parts of it. You know.
Yeah.
And then it gets into a conversation because someone might respond and say, well, it's not natural. Like these apples in the grocery stores aren't natural. These oranges in the grocery store aren't natural.
Oh
And it's
yeah.
like, but then it gets into a conversation about what it means to eat for something to be natural. Because I would actually say that this phone of mine is natural.
Yeah.
The computer in front of me is natural. Like, what does it mean to be natural? Because all these things are made up of things that we encountered in nature, and then with our brains that are part of our biology, which is part of nature, we created this stuff in front of us. So it's really not a matter of whether something's natural or not. If something's natural, it's not. If you're going to say that something's bad, it's not because it's natural, or that cannot. If something is natural, it can't be intrinsically bad unless you hate nature as a whole.
Right.
That's really what I'm trying to say. So I see.
Yeah.
Yeah, I don't like the whole. Yeah, I don't like that plant hatred type stuff. I don't really like it
No,
for
that
that
that's
reason.
why I've leaned into this. Into this in your comment sections a few times, and even in my discussions with people. Your when you talk about what's indicated or contraindicated, um, the like it curbs so many arguments with just logic and what can be shown to be most effective or most optimized.
Uh-huh.
And leaning into what's indicated as far as like the processes of absorbing slash eliminating fat versus absorbing slash eliminating glucose in the system. Um, like how in depth, because if I remember this right, there's less steps to processing and absorbing fat versus processing and absorbing glucose. Or do I have that back?
In
Uh,
terms of the absorption processes, I'd have to count them off in my head because I mean,
like
I think
like
they're.
the cycle.
Oh, in terms of metabolizing them.
Yeah.
Okay. In terms of metabolizing them in a cell, like using them to create energy or create ATP,
Hmm.
uh, you've got for carbohydrates, prototypical one glucose. You've got a 10-step process of glycolysis, um, which produces pyruvate. And
Hmm.
then when the I to G ratio is high, you will get pyruvate being oxidized in the mitochondria. So it goes through pyruvate dehydrogenase, then it goes through the Krebs cycle, then it goes to the electron transport chain. Um, so that's a few steps right there. So you basically got glycolysis, the transition stage, and then oxidative phosphorylation. For fatty acids, um, there is a for long chain fatty acids at least, there are a few more tiny steps, and then it takes longer to use a fat to create ATP through oxidative phosphorylation because it goes through cycles, multiple different cycles, to produce a bunch of acetyl CoAs.
Right.
So
So essentially, it's just reduced over and over again.
yeah, you shorten it by two carbons every single time until eventually you get uh, a two molecules of acetyl CoA produced at the end. Or in the case of it being an odd chain fatty acid, we'll actually get into this later on in the course, like around midway through. It's going to be there's three different pathways it could go through. You get a molecule called propionyl CoA, and it can be used to create ATP. It could
Hmm.
be used to create glucose through gluconeogenesis, interestingly enough, and it could also be used to create hemoglobin. Um, and so Yes,
So,
yes, there are more steps when it comes to fatty acid oxidation.
mhm,
Um, the beta oxidation process is actually a 4-step process, but like we said, it goes through those 4 steps multiple times for
right,
a long chain fat. Plus the prep the what's it called? Not the preparatory phase, because I just mentioned that the transition stage is also called the preparatory phase. It's the activation stage. The activation stage of
okay,
fat, you have to actually activate it first before it can even be oxidized. There's also that, fat enters a cell, becomes long chain fatty acyl CoA, enters into the mitochondria uh, via, you know, CPT1, and then it'll be converted into long chain fatty acyl carnitine, and then it goes through CPT2, and then it can start the process again after being reconverted into long chain fatty acyl CoA. Again, we'll be covering all that in the course, but that's those steps do add on to the quantity of steps. I think the most important thing to assess is not really the quantity, but the rate at which they they function, or the rate at which those steps occur. Um,
right.
and I think the major thing to look at is what our body. What do you think I'm going to say? What is our body most genetically adapted to use for
Right,
ATP production, which is clearly fat. But because if you use the how fast does glucose oxidation occur compared to fatty acid oxidation? Well, the 10-step process of glycolysis happens within 10 to 40 milliseconds.
right,
Actually, you know what? You know what? No, it's shorter than that. Glycogenolysis occurs within 10 to 40 milliseconds, and glycolysis is a subset of glycogenolysis, which means actually you're talking about yeah, less than 10 to 40 milliseconds. You're talking about like really fast amounts of
yeah,
time. Fats not so fast. Um, Especially considering that they have to go through the mitochondria, and oxidative phosphorylation is slower than the anaerobic pathways like glycolysis and all that, and glycogenolysis. So, yeah. But you also asked about absorption, but I don't know if you actually want to know about absorption, because absorption, I can cover that
no,
too.
it was more if you had to look at those processes between fat and glucose,
Mm-hmm.
um, taking everything into account, what they're broken down into, the byproducts that are left over, how efficient the body is at using the entirety a a fat or long chain fatty acid or a glucose, whether that be a short chain fatty acid. If you had to look at both of those processes, the byproducts and the efficacy at which they're used, which one seems more indicated for our what we've become genotypically evolved to withstand?
Yes. Well, I mean, I would go about solving that question a little differently. I mean, we should be looking at what we consumed primarily, and then
Okay.
see as a result of that, infer from that, like, okay, well, then that's the composition that we should be eating in terms of our diet. However, if you're going to go through that route, to assess what is appropriate for us to be consuming as a species, let's see, the byproducts of glycolysis. I mean, you've got water in the reaction, you've got NADH, you've got 2 ATP,
Mhm.
and then, well, I mean, look, glucose, if it goes through the entire process in a high insulin to glucagon ratio, um, then or in a very high intensity exercise situation, but we're typically talking about outside of that context. Um, you're producing 38 net ATP with a 16 carbon chain fatty acid, a very prototypical fatty acid like palmitic acid, saturated fat. You're talking about a net ATP yield of 129 ATP with byproducts. Well, again, when we talk about the byproducts, really what we're talking about, they're all being converted into ATP, so they're included in that number. So
Okay.
the two numbers, 38 for one glucose molecule and 129 for one fatty acid, that would suggest, well, fats may very well be more appropriate to consume. In terms of like bad byproducts, like the reactive oxygen species is a common one that is mentioned. People have suggested that fat is worse in that regard because cells that are oxidizing fat produce more reactive oxygen species or something. I haven't seen any direct evidence of that. However, I've seen the theory and what it's based on. Well, which is, well, when a cell is oxidizing fat, it requires more oxygen to metabolize a fat than it requires to metabolize, pyruvate, for example. So a glucose molecule in high insulin conditions. Except the it's an unfair comparison because of the fact that there are more carbons in a fat. So obviously it's going to take more oxygen. It doesn't mean that commensurate with each carbon, you're producing more oxygen in response to that. It's silly. Then the other theory is in regards to the fact that whenever you are oxidizing a fatty acid, and again, trust me, we'll get into all this when we get into these lessons. But most of the electron sort of ferries, I suppose you could say, that they ferry because they ferry electrons to the electron transport chain. They're ferried, I suppose. They're in the form of FADH2, and FADH2 enters through complex 2 of the electron transport chain and not complex 1, and they cause the cell to basically function slower, or the mitochondria to function slower, because they skip complex 1. It's all a bunch of reductionist science that hasn't actually been borne out on a broad basis, and is also completely failing to understand that when you are going to look at a system or a mechanism that you form a hypothesis from, you must, as I just said, you must be able to establish that on a broad basis. What is the net result of people oxidizing lots of fat? In those studies, is it associated, that's the key, is it associated, because that's really all you can look at. Is it associated with lower ROS production or higher ROS production? Is it associated with better performance or worse performance in that regard? Well, seems that the net results, the net effect of all of that, or the, again, purported effect, is a reduction in ROS production on the system-wide level, and not an increase. Not to mention that if you're going to sit there and say, oh well, there's an increase in ROS production in a cell whenever it's oxidizing fat. Well, who's to say that the body doesn't mitigate that by upregulating antioxidant status in the form of glutathione? In which case, well, then again, the net result would not be more ROS or more damage from reactive oxygen species, would it? There's also theories that glucose itself, when pyruvate is being oxidized, so from glucose metabolism, when it's being oxidized, well, it goes through, a lot of molecules mainly go through complex 1 of the electron transport chain, which means that it goes through an extra complex, which means that it's introducing another opportunity for electron leakage, and therefore oxygen to acquire those electrons and form superoxide or hydrogen peroxide, so more reactive oxygen species, and break down a bunch of other organelles. So they're all theories. They're all theories. So what are we dealing with here? It's cool. Like if it is true that on an individual cellular basis, you've got, when you're oxidizing a fat, there seems to be some more ROS production. Also, I'd be curious. Well, no, I'll put that aside. But and the mitochondria maybe function slower than it does if it's oxidizing pyruvate. That might be interesting. That might be okay. That's cool to see. Like, okay, whatever. But in terms of like extrapolating that to the entire system-wide level, and not only to the overall system in which it is being studied, but every single system, so every human being on the face of the planet, irrespective of phenotype or genotype. Mostly phenotype in this respect, because we're talking about mitochondrial function, which is quite ubiquitous in terms of how it works for every human. Just phenotype can influence the rate at which they function and all that stuff. But still, I mean, you're talking about billions of different phenotypes.
Right. I think with the elimination part of that between the two, my initial thought process was very, very superficial in just the fact that if if we take in too much in one sitting, if you eat too much animal fat, your body will just break it down and pass it.
Oh,
You,
yeah.
and then with the elimination of glucose, it's your body pushes this insulin with almost a sense of urgency to
Uh-huh.
remove it from the bloodstream before it gets toxic.
Yeah, yeah.
Um,
Yep.
and I think that's where I was with the elimination is that the body doesn't have to do anything but pass excessive amounts of fat
Yep.
versus the insulin production to eliminate glucose that can over time lead to beta cell fatigue. I, I think it is.
That's what they call it. I think that what they mean by beta cell fatigue is actually just beta cell damage, so they fail to perform their function. That's what I was referring to earlier. When something
Yeah.
transgresses from type 2 diabetes to type 1 diabetes, they'll often call it beta
Mm-hmm.
cell fatigue because over time it starts to release less and less insulin. I think that's just a function of it being damaged slowly over time, that it fails to perform its function properly.
Okay.
Because I don't think
Yeah.
a cell actually has the ability to fatigue itself
Mm-hmm.
without, well, not without implies that there is an ability for, I don't think a cell has the ability to actually become fatigued because it's all chemistry. So an equilibrium doesn't just fail to continue because it just does something for a long period of time. I think
Right.
what's actually going on is that it is adapting to the circumstances in such a way as to prevent further damage of itself by
Mm-hmm.
perhaps, um, you know, in the case of, like, this might sound irrelevant, but neurotransmitters. If you get too much of a neurotransmitter, neurons themselves can die because you can actually toxify them. And as a result of that, you'll actually see that as they divide more and more, you can actually get a downregulation of the transporters or the
Mm-hmm.
cell receptors that bind on that the neurotransmitter binds onto. So you become less and less sensitive to the neurotransmitter. So this is
Yep.
one of the biggest times that this is talked about was with dopamine.
Yep.
So if you spike a dopamine all the time, you can actually damage your brain, and as a result of that, the cells, they start to downregulate the binding ability for dopamine onto those cells. So you actually become less and less sensitive to dopamine. Um, in the case of beta cells on the pancreas, you could be having a similar situation where you have GLUT2 on the outside of pancreatic beta cells. And so those are glucose dependent. And if you have so much glucose going through the body that it's just shoving in glucose and it's becoming damaged over time, you could actually have a downregulation of GLUT2, perhaps. I'm not sure of this. And as a result of that, you're actually, the amount of insulin that's being secreted is going to just go down and down and down over time because it's trying to preserve the life of its own, its own life.
Yeah.
So it's either that or the cell is just becoming so damaged that it's actually failing to perform its function in general, which they're very similar phenomena. They're very similar because if it's becoming less and less sensitive to the glucose in your bloodstream,
Mm-hmm.
that's still as a function of it being damaged.
Right.
So, not sure, but I'd have
Yeah.
to look into it more. There's a lot of things that I have to look into more. Because most of the time, a lot of people don't know that I don't spend a lot of my time looking at the scientific literature, actually. It's something that's one of the next steps, but I've spent most of my time looking at fundamentals because a lot of times you can infer like 90% of what you need to infer from the fundamentals. And
Yeah.
so that's one of the reasons why when people ask me specific questions, I don't have particular answers to them. Like, oh, what are the implications of this? Do you know any evidence of this phenomenon? Like you just mentioned, like low salt and insulin rising and stuff like that. I know
Yeah. Yeah.
if I went to actually go on that venture and go in there into the literature and dive deep into there, I know that I'd be able to do it. It's just that I
Right.
haven't. Like I know how to
Mm-hmm.
interpret the data. I know how to interpret the numbers. So whenever I'm faced with research, I know how to just look at the numbers and just be like, okay, and then like look at the methodologies and notice the biases. So there's response bias, there's non-response bias. You got a lot of biases like that. And then understanding whether the methodology was the most appropriate for what the goal of the investigation was. I'm able to look at all that, but I haven't actually looked into the literature myself about those things. So typically what happens is people like you ask me a question like that. I'll write it down, and then on my own time, I can go and actually look at it. That is one of the things that AI is actually really helpful with, because I used to, before I refused to use AI. I thought it was like cheating. So
Right.
I got on the AI train late. Like I got on it really late. Like I wrote this book before even the second edition of this book,
Yeah.
I finished it before I ever used AI,
Okay.
ever. So by the way, for any critics out there that have said exactly that, which is your book was written by ChatGPT, um, I did, but it was right around that time that I actually started. I went, oh, okay, so I can actually use, instead of going on Google Scholar and spending
Mhm.
hours on Google Scholar trying to find look into looking at search terms and all that stuff and
Yeah.
keywords to try and find
Chasing
studies that
down
I want.
mechanisms and yeah.
Yeah, instead of doing that, I was actually, I could just look up like, oh, hey, ChatGPT, look into the Journal of American Medical Association database and find all studies that have keywords like this that are that are studying this thing, and it'll
Yeah.
just, and then I could just look. I'm like, oh, okay, so I can actually just look at this now instead of spending hours. It speeds up everything. I'm like, okay, so now I can look at the integrity of these studies.
Yeah.
Like, you can't trust it fully because there's sometimes where it fails to access everything.
Yeah.
Like, but so it's a trade-off. It is a trade-off. So I mean, the best thing to do is actually to combine it with your own searches on Google Scholar. Like if you use AI first, look at all those studies, and then you look at Google Scholar yourself and do the same old thing.
Right.
And then you combine the stuff, like, because you might find studies that it missed.
Yeah.
Um, Whenever
Yeah.
AI
But
was really starting, it was getting like links wrong. It would cite you a study, and the study wouldn't even exist. So I mean, it's gotten better now with that, but yeah, yeah,
yeah, it definitely speeds things up. It's a far cry from when I was in grade school, or at the very infancy of the internet in junior high. That I had two bookshelves of gold lined paper with the said Encyclopedia Britannica on the spine of the book, and
yeah.
that was my whole world right there. That was all the knowledge in the entire world that I ever
Yep.
knew. So it's yeah, the access to information, like my son that's 13 years old, the amount of information that he has access to is just wild.
Yep.
It's it's
No.
insane. He can learn
Yeah.
he's taught himself how to code in three different languages. He's currently coding his own game on Roblox.
Wow. Yeah,
Like
that's
it,
cool.
it, it's insane. Um, yeah. So I want to get back to insulin real quick because it as much bad as there is said about insulin, it's not demonized. It as it shouldn't be because it does have a purpose. It does have
Yeah.
a crucial role. Um, and one of those, and you've mentioned this in one of your videos I remember seeing, is eating enough protein in a large enough single sitting is crucial to getting insulin high enough to encourage electrolyte retention, to avoid heart palpitations, uh, feeling cold, poor recovery, bad sleep, not eating. And I think this comes from people being carnivore, um, and a very, very low carb diet, eating smaller meals throughout the day versus having large or sufficient enough amount of protein to stimulate that insulin secretion
Hmm.
during
Yep.
their meal. Um, what? Why is it so easy to eat small portions? And you hear stories about people under eating on carnivore. Why is it so easy to do that?
Oh, well, there's a few reasons that I could think of. Number one, a lot of times people are eating ground beef. It's a very common thing. And I think
Hmm.
that ground beef is just naturally more satiating. I can get down a lot more food if I don't eat ground beef and I eat steak instead. I can get a lot more protein down. I think that there, because ground beef has more than just, like, it's like there's a lot of stuff in ground beef besides just
Right.
regular old muscle meat. You know what I mean?
Yeah.
Like there's a lot of connective tissue in there and stuff like that. So,
Okay.
um, but other times I'm seeing that it's just naturally when it has more protein and it has more fat in it. People are so
Hmm.
not used to being satiated with smaller like you said why is it so easy to eat smaller portions? But I feel like there's a conflation here with small portions and necessarily undereating. Because I'll tell you something,
Right.
there's a lot of people that I have an anecdote in my book actually from someone that said this, as well as even just my own fiance said she would be eating like half a pound of ground beef when she went carnivore, and that was like all she would eat for the day. That's all she needed.
Yep.
I'm not. It was
Yep.
really. I was actually concerned at first. I was like, um, no, that doesn't
Yeah.
seem right. But no, like she wasn't hungry. She wasn't. I mean, it was really impressive, and so we have to be careful with not conflating the terms like under eating and then also
Right.
also eating less.
Yep.
But in terms of like people that are actually under eating, the one of the biggest culprits that I see seriously is ground beef consumption. I'm not
Mm.
even kidding. It's either that or it's people that have had past eating disorders that have really disrupted their satiety signaling and
Okay. Yep.
hunger signaling. They were like bulimic in the past. They were anorexic in the past. They had an eating disorder like that, and so then whenever it's very similar to the phenomenon. It's very similar, but also not because they're different from each other. But like people that are really like starving in other countries, if they're given a lot
Yeah.
of food at once, there's a syndrome called refeeding syndrome, and you can
Oh
actually
yeah.
get really 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 sick by feeding them more food. Like in even if it seems like a really small amount,
Yep.
if it happens at once, big problem. And so you have to be
Yep.
like really careful with it. And
Like
so
breaking a fast. Break a long fast with bone broth or something, or a dehydrated person that slams a bunch of water when they
yes,
finally get to something.
yep,
Okay.
exactly. And so I think that those are probably. Do I know the exact mechanisms behind that? No. I mean, it's clearly an adaptation to just not having eaten, of course, but
Right.
it's those are the biggest culprits that I see. There's some people that you know I can say that if someone is having difficult, if someone is still having difficulty, so they're not eating a lot of ground beef, they didn't have previous eating disorder problems or anything like that, and
Hmm.
they seem to still be having problems with under eating food. I would consider maybe having like some shrimp or some leaner like leaner meat like
Hmm.
chicken in small amounts because
Yeah.
um you can I can just tell you from my own experience the amount of protein you can get down if you just ate chicken and shrimp is
Oh
like insane. Yeah, hundreds of grams if I wanted to. Hundreds. Am
yeah.
I saying you should do that? No, I'm just saying like that just goes to show though that if you're having a problem with insufficient protein consumption,
Yeah.
there are ways around it because it's like don't make it the base of your diet, of course. Like I think that
Yeah.
it should be
Right.
ruminant meat, of course. But if you had that as like a supplementary food alongside something, like okay,
Hmm.
go ahead,
Yep.
like that fine. Um,
Yeah.
those are the biggest culprits I see though, is people with past eating disorders, and then also um, eating too much ground beef. I know that might sound so weird, but I was shocked to see how many people actually came forward and said the same thing. They were like, "Oh, now that you said that, yeah, I realize how little I eat when it's ground beef instead of like a steak. I eat a lot
Yeah.
more steak than I can with ground beef, like
Yeah.
actual burgers or something like that." So,
Yeah. Eat hamburger patties versus ribeye steaks and see which one you eat less of.
yep, yep, 100%. Yeah,
Yeah.
it's very interesting.
It was very early in my carnivore journey when I was doing all my research, and I had dabbled in different ketogenic ways of eating. And don't hate me for this, okay? I didn't know, all right, but I was counting my calories. I was adding up my macros. I was
Uh-huh.
doing all the math. I spent hours just it looked like a college exam to come up with like three recipes that met a certain macro range in these in these three different things. But then more and more as I dove into carnivore and I started learning to listen to my satiety signals and my hunger signals. I was like, you know what? I think the body is more nutrition based and not calorie based, like we've
Yeah.
been programmed to believe. Because I was eating less, I was losing fat, and I was still putting on muscle. I was still gaining strength. Um, and it just and yeah, so that was my conclusion. And then listening to your videos when you start talking about the the nonsensical things that people say about calories or the logic behind it that just isn't there.
Yep.
Um,
Yep.
it really blew my mind when you told me that they could be off by as up to much as 20% on the
Legally, yeah. And
on
that's
the right, yeah,
yeah, and that's because of the fact that you can't even directly they could well, when you measure them, you're not measuring them, you're estimating them because you can't directly measure energy. So you're actually having an error of 20%. There's an error band of 20% around the signal that you acquire. And
right,
so they therefore have to make that legal to report a value that's out by 20% in either direction because if not, then all these people would get sued. But it's not even
right,
really their fault because you can't measure the exact number. So they have
yeah,
to they have to make it legal for that to happen. But it's just important for people to understand that's what's going on. I don't even think that calorie numbers should be on food labels in the first place.
no,
There's no reason for calorie numbers to be on food labels. It's important, I think, to have the mass value of the food on
mm-hmm,
food labels like we already do.
yep,
And of course, the ingredient labels. Just get rid of the calorie number. Just get rid of the calorie number entirely because that is not what your body deals with. A calorie does
right,
not tell you the nutritional value of a food. And just as you said, if you consume 1,000 calories, quote unquote, consume 1,000 calories. If you consume 1,000 calories, um, and it's all of a bunch of absolute junk, your body might very well be hungrier
right,
because you didn't give it what it needed. Because
right,
it's not about calories. Calories aren't nutrition.
mm-hmm,
It's nutrition that's nutrition. And the nutrition that we're talking about is mass because we're open
yeah,
systems. We
yeah.
deal with two variables, not one.
So then if you want to talk about math, I want you to consume 100 grams of gummy bears, and I want you to consume 100 grams of ground beef,
Yep.
and now let's start looking at the physicality. Let's start looking at the mechanism. Let's see what happens when you start
Yeah.
comparing these two instead of trying to compare calories to calories.
Yeah. Exactly. No, I completely agree. I completely agree with that. It's there's so many problems with that calorie number and the model
Yeah,
itself. I can go on and on. I can probably list about 10 things.
right. Um, have you heard about this? Have you heard about this new alpha gal meat allergy that's
Oh yeah.
happening,
Yeah,
going
yeah.
around
I've known
from
about it for a long time.
the
Yeah.
Lone Star tick?
Uh-huh.
Like what what I've read a couple of different things. But what is it reversible? Because everything I'm reading, this is like the end all be all, and you're never going to be able to eat meat, ruminant animal meat again a day in your life.
Yeah, it's one of those things where it usually takes, I think, about in the people that have been studied 6 months to a year to get rid of it. It usually
Okay.
just goes away.
Yeah.
Um, but I think that I've read that some people may not, they never see a regression of it. However, I'm very, very skeptical of that idea because, and I'll tell you why. It's because it's usually done in people that are not eating well in general. We all know that it's
Okay.
far harder for you to get over something like COVID. I mean, whatever it
Hmm.
may be, like any sickness. Bleep, bleep.
Yeah, right.
Um, whenever, whenever they're like, that's when you get the whole long COVID thing, like that. Oh, I never got
Yeah.
over it ever. It's like, yeah, well, how you eat.
Right.
I think you can extrapolate that basically to every other sickness.
Yeah.
And not to mention, if there's one thing that the standard American dieters and the gym bro standard, like count your macros type people, type groups
Mm-hmm.
of people, and carnivores can all get around. Um, we're not going to let the thing not have a cure. We'll find a cure like that can actually cause it to be cured instantaneously,
Right.
because no one's going to give that stuff up. No one's going to give it up. Okay, and so I'm not super super worried about it. However, I am aware of it because it's important to be aware of if you're someone that eats a lot of meat and it's the basis of your diet. The things to avoid is basically all mammalian products if you have the problem, but
Right.
basically anything from poultry and but yeah, so anything from poultry is fine, and I think there's seafood as well. Seafood is fine as well.
Okay.
So seafood and poultry. So that includes eggs, by the way. So you can have eggs, you can have poultry,
Right.
you can have seafood, and so there's ways around it. But unfortunately, dairy and red meat, that's something that you're
Right.
going to have to avoid unless you are able to withstand some slight negative side effects if you're someone that isn't extremely sensitive to it. Like there's some people that like
Right.
they don't become like anaphylactic or anything like that. I think the
Yeah.
severity at which someone's going to respond to it, like when they have the condition, because that's another
Mm-hmm.
thing. I wonder how much, because I always think of things from a scientific, like statistical point of view.
Yeah.
When we talk about like all these people that are claiming, oh well, this disease is like really 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 bad and it might kill you and all this stuff, and you might never be able to eat meat again. How many people have been bitten by the tick, theoretically,
Mm-hmm.
that did not go to the hospital because they actually themselves did not become symptomatic? I think there might be a lot of response bias.
And I think that there's a huge amount of response bias. It speaks to the normative ranges when it comes to blood pressure and cholesterol and everything like that.
Yeah, it's
Well,
all based on people
you're
that go to the clinic.
they go to the clinic.
Exactly.
If if I'm not exhibiting any symptoms and I feel just fine, but in fact I am infected with, insert sickness, I'm not gonna go to the clinic. I'm gonna go to work. I'm
Yeah,
gonna make my
exactly.
breakfast and go on about my day.
Yep. So when people,
So
yeah, exactly. When people say most people, you can expect this, you can expect that. It's like,
right,
no, but I wasn't in your sample, guys. Like
right,
that's not true. So I'm not saying that. Clearly, what we know is that it can cause those things. Like
yeah,
you may very well expect that to happen, especially if you're dealing with a demographic of people like in the carnivore space. Most of the people that come to carnivore they're people that are really sick anyway,
yep,
and or they are people that they're just sensitive people in general. Like if they do come down with something, it's bad. And
yeah,
so I'm not downplaying what it can cause, but what I am questioning, and not questioning in a cynical way, but just wondering, really is probably the better word to use, is how many people have come down with that problem that do not have any symptoms at all. Like there's still some hope there.
yeah,
Um, and not to mention that even of the people that have been reported to have the condition and have the sickness, a lot of them, they're not severe, so they might break out, they might have they might start getting itchy or something like that, nose running, so,
hmm,
stuff that sort of seems to mimic like histamine intolerance a bit.
yep,
Not to say that's not a problem, but I mean it's better than full anaphylaxis like some of these people have.
yeah,
Um, but even within those people, they can see remissions within 6 months to a year. If they get bitten
hmm,
again, the clock sort of resets, but it doesn't mean that
yeah,
it's completely permanent. So, what fraction do the people that do continue to have it right now, which by the way does not mean that it is permanent, it means they still have it. That does not mean that it is permanent.
right.
You can't really you can't do that. You can't say that. But what fraction do those people actually make up in all of the people that have ever been bitten by the tick that didn't even realize it? Not sure. What people have, I think there's a subset of people that have said that this is going to be used for like bioengineering, making us super um, sick to me. What I will say, I could be overly optimistic, but I think that we're sort of, I think that we're sort of over that a bit. I don't think we're completely over it. I think we're sort of over the whole like plant-based, that was like a 2020 thing where everything was
Okay.
plant-based. The plant-based industries were huge, like
Yeah.
the Beyond Meat and all the
Oh
plant-based
yeah.
stuff. I think that since those have died like completely, like they're basically just been wiped off. No one likes them. No, the whole agenda has sort of like, it's sort of in a way, at least on the mainstream stage, the main stage, it seemed to fall out of style. It doesn't mean that it can't come back, and it doesn't mean that they're not still like there's people that are still wanting to do that. I'm not pretending that at all. I would like to think that I'm a little more rational than that. But I think that was far more of a threat a few years ago than it is today. And so I'm more
Right.
optimistic that that'll start dying down fully, like very soon. I mean, it's because to pretend like veganism itself is completely dead is not true. That's not true. Veganism isn't dead, and there's still people being recruited into the movement, like more and more and more. Like that's
Right.
still happening. Um, but I'd like to think that that's not. It's not as much of a threat anymore. And so,
Yeah.
I don't want to come across as naive. That's why I keep emphasizing I'm not saying that I'm just turning a blind eye to it. I'm just saying
Right.
I think I'm a little more optimistic about it. I don't think that that's as much of a threat anymore. But I did actually, I have a reel saved on my Instagram from a long time ago, years ago, and it's in my reaction folder because I actually have one of those. Like, oh, things to react to, and
Yeah. Yeah.
one of them was one of the I think it was a WEF spokesperson, or at least someone was on the panel. They
Okay.
hosted someone that was a bioengineer that
Hmm.
was talking about. It was a clip that went relatively viral, so people may already know what I'm talking about. They were like, "Oh, look at this great thing that we can do. We can actually engineer people to be allergic to meat to stop people from eating meat because of the whole
Yeah.
climate agenda thing."
Yeah.
Um, like I said, the climate agenda, the climate worship, was really what it is. I think that we're moving away from that, but that may very well only be temporary. We'll see. It might just be the whole ebb and flow of culture, which is just, oh, it's dead now for, I don't know, 4 years. I don't know why I picked that number.
And
4 years, and then the
and then
next 4 years.
rediscover it like a puppy that finds an old toy.
Yes, yes. I have no idea where the 4-year figure came from. No clue.
Yeah, it's um. So before we dive too deep into any kind of
Yeah,
politics,
yeah. We'll stop. Yeah, we'll stop. We'll stop there.
let's see. So when it comes to, I don't know, this is like a maybe a bad C word. When it comes to cancer,
Okay. Yeah.
um, there's been stuff that I've read, mixed things that have come from both sides. Starving or slowing cancer growth by lowering blood sugar through a low carb diet. Do
Yeah.
you think that there's any validity to that?
Um, there's a lot of nuance there because I just recently had a conversation with someone where I said that I don't think it is that simple in every single person. Because, first of all, we need to understand that cancer cells themselves, depending on the cancer cell, they can use glutamine, which is,
Yep.
you know, a carnivore diet is teeming with glutamine because it's an amino acid. So,
Yep.
um, it may not be that simple. But even in the cases where the cancerous cell is not primarily relying on glutamine,
Hmm.
who is to say that the liver, if you're restricting carbohydrates from the diet, can't just create more glucose to subserve the demands from the cancerous cells? Um,
I think that the argument there is that uh, cancer consume, or these dysfunctional cells consume up to like 40,000 times the amount of glucose
yeah,
that normal cells, creating the Warburg effect.
yeah, mhm. Yeah, yeah, and that's what I mean. If you cut out sugar entirely, the idea is that, well, you're starving the cancerous cells of glucose. However, we know that whenever you're not consuming the glucose, your
Mm.
body will just produce it. So who
Right.
is to say that the cancerous cells, whenever they take up that glucose that you're producing, won't just stimulate to the liver to create more glucose? Because we have to remember that the cancerous cells are not
Mm.
foreign cells. They're domestic
Right.
cells. So they can
Mm.
actually exhibit some of the same chemical pressures to get the liver to just upregulate its production of glucose to serve their demands.
Ah.
And that may explain why some of these ketogenic metabolic therapies actually are not working in some people, because sometimes they don't seem to work. There's two different reasons that I can think of, which is that one, and then also, as I just referenced, the glutamine situation. If you're
Yeah.
not cutting out glutamine, then what happens if you're not, but there's a study that I'm thinking of that actually did a plant-based keto diet,
Okay.
which it doesn't have a lot of
Of
glutamine in
glutamine.
it at all.
Yeah.
And they did not see any remission in cancer. In fact, some people actually had a worsening, a progression of their cancer.
Huh. Okay.
I don't think that it actually measured. I don't think it measured glucose production rate at the level of the liver to see, like, to compare, like, before they quit the glucose and after, if the rate of, well, no, that wouldn't matter anyway. Of course, the rate of glucose production in the liver would go up if they cut carbs out. Really, the comparison should be between one person, like if that person didn't have cancer, what would the production rate of glucose be on a ketogenic diet in their from their liver versus when they do have cancer? But you can't do that study because they have cancer. Like, you can't just
Right.
compare them to their non-cancer adjacent. So
Right.
that
Yeah.
that won't work.
I
So
would be curious though if 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 that would hold true if the cells, while dysfunctional, are still domestic, if they were able to send those hormonal triggers or whatever to the liver to cause an upregulation beyond what normal gluconeogenesis would produce.
yeah, well, that's basically my point, actually, because I mean, well, no, okay, I see what you're saying. You're saying there's a there's a question as to whether there's sort of a maximum rate at which the liver can produce the glucose.
Hmm. Yep.
So even if the cancerous cells are sending signals that they need glucose, wouldn't the liver at least cap out at some point? I think that's kind of what you're saying. Like,
Yeah.
could
Or
they?
would the cancer cause the liver to like overplot?
Yeah, yeah. I'm not sure. I mean, from my understanding of metabolism, I think that because here's what's going on: the cancer cells are taking up lots of glucose, and your muscle cells, your red blood cells, and some of your brain, but mainly the first two, your muscle cells and your red blood cells, are taking up. If you're in a ketogenic state, it's taking up a lot of glucose as well. But if there's more glucose that's being absorbed from the bloodstream, and so there's more glucose demand, then what's happening is these cells are becoming, drained of ATP in some sense or another, because of course, well, that's what happens in things like red blood cells. Whenever you don't,
Right.
you need the it can only use glucose because it doesn't have mitochondria.
Hmm.
And then also things like the muscle cells, whenever they don't have enough glycogen for adequate muscle function and stuff like that, then it's going to
Right.
send signals to the liver to produce more glucose, because it will need to, those cells need to survive. When it comes to the maximum rate of production, I don't think there really is going to be one if the cells are suffering from I mean, not hypoglycemia, because emia is with respect to the blood, but so to speak, if you're becoming hypoglycemic, if there's a hypoglycemic pressure, then I think that there's no cap the liver will attain that will prevent it from producing the glucose that is required. If anything, what happens is you'll get there's a phenomenon called, it's in the later stages of cancer, called cancer cachexia, which is
Okay.
where the muscle starts getting broken down into glucose because the cancer has grown so much that there's such a high glucose demand. There's no cap that the liver has, because
Right.
they will waste away. It's the reason why cancer patients waste away with or without fat loss, by the way.
Okay.
It's because their muscle's going away, because their muscle is actually being able to be, your muscle has amino acids, and those are a primary gluconeogenic precursor. So
Right.
um, I don't know. I would like to talk to someone like Thomas Seyfried about this, because to get his take, because I just don't understand how it would be possible, like, to starve cancer in that respect. People have
Yeah.
even tried to cut cancer cells off from the blood supply, and what happens is you get neovascularization happen, where the body will
Hmm.
just produce new blood vessels to attach those cancer cells back to the main blood supply. Because
You know,
again, it's a domestic cell technically.
yeah. There's actually, I made a note at the end of this. I saw one where there was an attempt to implant brown adipose tissue
Yes.
around the cancer.
And then they did
Um,
seem to see some benefit.
and then they saw some benefit, but then again, I guess brown adipose tissue is not a dysfunctional cell. So
Yeah.
I
So
don't I don't know what.
the
Yeah, what
idea,
are the mechanics behind that?
the idea behind that is that brown adipose tissue takes up a lot more substrate than another cell that does not have uncoupled mitochondria.
Hmm,
Basically, the brown adipose tissue has uncoupled mitochondria, which means they take up more substrate than is required for them to create ATP.
okay.
So that's why they're uncoupled. Usually it's 1-to-1 ratio of substrate to ATP that a cell takes up. In
Right.
fat, you have a phenomenon whereby you can actually have it become beige fat, so to speak. So brown, yeah, it's
Right.
brown fat,
Hmm.
um, or a stage between brown and white, where it'll take up more substrate than is actually required to create ATP. So the ratio can be like 3 substrate to 1. So
Okay.
they're actually looked at as inefficient. And what happens is it's not really inefficient, really, because brown adipose tissue is designed to keep you warm through non-shivering thermogenesis.
Right.
What happens to those other 2 substrate units, so to speak, in the ratio? It's not that they're just completely wasted. They're being used to create heat because heat is a sign of chemical inefficiency. If you react 2 things together, you'll see
Right.
like sometimes there's a lot of heat that's released. All
Hmm.
of that heat is a sign of the chemical inefficiency of the reaction. So if there's no heat that's released from the reaction, it was a really efficient reaction. All the
Right.
mass was sort of conserved in that reaction. Some of it though can be released as heat, and you'll have, you know, two reactants going to form a product. If the product has less mass than the combination of the 2 reactants, then you know that you've lost some mass as energy, usually in the form of heat. It's
Yep.
because yes, it's exothermic. And so what they're doing is they're putting brown adipose tissue around the cancer cell. So if the cancer cell causes a pull of glucose, there's a chemical pull for glucose to the cancer cell, PULL, not POOL. The brown fat will take it up in its place because it's very energy intensive to create the heat.
Right.
And so that's a way that they've tried to compete for cancerous. They've tried to compete for glucose uptake. You know, they've tried to get cancer cells to be starved. Um,
Right.
and they're not being cut off from blood supply, but at the same time I just don't understand why would that not also result in neovascularization, because at the same time, even if they're not directly cut off from the blood supply, if all of the glucose is going to brown adipose tissue surrounding the cancerous cell, wouldn't it find ways to still produce more blood cells to circumvent that? Like maybe not, I could be completely wrong. I just I think that cancer cell, like I it's not like I mean, this just goes to show how much of a non-zealot I am about carnivore. Like, I'm not going to sit here and say it's a panacea, like, or a Catholicon. I don't,
Right.
I just don't, like I said, I want to be wrong. Wouldn't it be awesome if you could just say that carnivore is the be all end all when it comes to,
Yeah.
curing cancer? That would be awesome. Like,
Yeah.
that would be great. I just don't know. Like, I feel like once you've gotten to the point where you have cancer, you, depending on your situation, you may have no choice but to undergo some sort of chemotherapy. Like, because
Yeah.
the goal is really to not get cancer in the first place by not damaging your cells all the time and your mitochondrial DNA,
Hmm.
because that's the common denominator with all cancer cells is poor mitochondrial function. It's a slowed rate of it, and
Right.
it's almost like a complete shutting off, like a complete inhibition of the mitochondria. They're not they still respire, so that's why some cells, they say that cancer cells can't use fat. It's not that they can't use fat; they use fat like this much, like really really low amount. Um,
Right.
they still respire. That's really slow, and so the body sort of, if the mitochondria are typically in the driver's seat and the rest of the cells in the passenger seat, they basically switch sides whenever you have cancer. So now the rest
Yeah.
of the cells in the driver's seat, it's using glycolysis. It's going into its prokaryotic sort of archaic mechanism. So glycolysis, that's why in the
Right.
course I call it
Yeah.
the most archaic pathway, because it is. Like, it's one of the first pathways that was ever utilized by organisms before oxidative phosphorylation was ever a thing, before mitochondria existed. So that's a long time,
A
as the
long
story
time.
goes. Yeah.
Yeah.
as the story goes. So, um, given those facts, what we can say is, okay, if that's the common denominator is mitochondrial dysfunction, and the
Mm-hmm.
common denominator of the mitochondrial dysfunction is mitochondrial DNA damage, which sort of are in a positive feedback loop. Mitochondrial DNA damage can cause mitochondrial dysfunction. Mitochondrial dysfunction can cause mitochondrial DNA damage, or things that cause mitochondrial dysfunction can cause mitochondrial DNA damage. So it's like a positive feedback loop situation. If that's
Right.
the case, what do we do to mitigate mitochondrial DNA damage? Well,
Right.
I mean, eat a diet that is in accordance with what your genes, which involves DNA, that's like what we're talking about when we talk about genes,
Yeah.
are evolved to literally withstand. I mean, that's like that's the most obvious, or that's the most like that's a situation where that um, argument or that position becomes most realized and most obvious is whenever we're
Yeah.
talking about actual gene dysfunction and
Right.
alterations. So it's not to say that anything that has an impact on your genes, like nuclear or mitochondrial or otherwise, is something that is carcinogenic. That would be, I mean, everything has some sort of oxygen itself can damage DNA. We wouldn't say that oxygen is carcinogenic, right? Like you
Right.
have to be careful with classification. So I'm not going to sit here and say, for example, that glucose can damage your it does damage your nuclear and mitochondrial DNA. It has the capacity to do that. By that logic alone, can you say that glucose is a carcinogen? No, you can't say that because
Right.
there's a lot of nuance there. I mean, like I said, for the same reason you can't say that oxygen is a carcinogen. But
Mm-hmm.
the best way to do, like if the Darwinian principles of evolution are true, it's the prevailing scientific theory for a reason. If they're true, then from every inference that we have, what you should be doing is looking at what our genes evolved to withstand, mitochondrial DNA and nuclear DNA, and say, okay,
Right.
well, let's stick to that, because if we don't stick to that, you may risk things like cancer or anything else that's undergirded by mitochondrial DNA damage and or mitochondrial dysfunction.
Right.
So yeah.
Yeah. Um, you know, Eddie, I think I mean we're 2.5 hours in. I think I'm done.
All right.
I think
Awesome, man.
I think you checked the boxes, but it probably won't be very long before I'm sending you another email ready to do round three.
Oh yeah, well definitely. I mean, look, all these conversations serve to help both of us, but they also serve to help the viewer out.
Yeah.
And so it's a win-win-win for all of us. The more we do this, the more that I can get videos out that actually explain these concepts to everyone else as well. Because I think one of the ways that people can learn is as much as it's really, really, really popular to um in order to garner an audience really effectively
Yeah.
is to be like really, really controversial and really, you know, convicting and acrimonious. I think that there's also a completely different subset of people that like, there's two types of people. There's the people that like that, and there's also the
Hmm.
learners. And this is the way to learn, is by actually listening to other people have conversations, which is one of the reasons why the whole course that we're building has been
Yeah.
really helpful for me. Like it's benefiting me as well as,
Right.
of course, benefiting all of you. You're helping to, I mean, you got a massive discount and to help
Yeah.
out to actually help build something like you actually, that's just, it was a really good investment. So it was but it was a good investment for both of us. I'm investing a lot of time doing this, but it's helping me because I'm hearing, while I'm talking to you guys, I'm hearing questions from you that I didn't even think to ask. Some of them
Yeah.
I did think to
Right.
ask, so I know the answer to them like reflexively, but others I'm like, oh, you know what, I should write that down and look into that myself. Like it
Yeah. Right.
so I want to provide that benefit to, you know, the viewer as well, um,
Yeah.
with these conversations. So no, they don't just serve to help you or me; they serve to help everyone else as well. So
Yeah. No, I love it. The our last interview that you did, and you kind of broke it up into smaller chunks, which
that's what. Yep.
after you started posting them, then I was like, okay, and then I grabbed the file and I started breaking it up into smaller chunks on my channel. Um, but I mean, every morning, a couple days a week, you know, I'll sit my son down because he's into this. He's a science buff. he's got it.
Good. Good. Yeah. Start
But
young.
yeah, he loves diving into this. So yeah, he'll ask if we can flip on one of the little 5-minute things or 10-minute things that you and I dove into on our last interview and go through it. So
One of them uploaded today, by the way. Another
oh
one
yeah,
uploaded on YouTube
another
today.
one uploaded today.
Yeah, yeah, from our last conversation. Like it just they span for like months, man. It's like
yeah, right.
yeah.
So but I love it, and I'm getting the same benefit out of it as you. Just being able to look into these things. A question pops up, I dig into it a little bit, but still having my question, and then give it a chance to get some back and forth with you. It's
Yeah.
yeah, discussion is what it's all about for us
Yeah.
to just be able to go back and forth on all these things.
Yeah. No, for sure. Anyway, yeah, yeah. So, it was good talking to you, for sure. And we can make this a relatively regular thing. I mean, I think that if there's something for you to talk about, then there's no point to not have the
Right.
conversation, So, yeah, for sure. Just get a hold of me if you have another list made, or you fill up the
Mm-hmm.
list that you already have again, and
Yeah,
we can schedule another. So, yeah.
absolutely. And for you and your audience, if you're ever curious about stoicism, keeping the mindset right, as well as our nutrition and our food, it's come visit me over at Ascending Stoic on
Yes.
YouTube.
Do that.
Come
I'll
check it
link
out.
Yes, I'll link his channel in the description below so that you can check that out. And yes, subscribe and watch the videos and like and comment and all that good stuff. All the normal stuff. Because yes,
All the
there's
things.
some yes, all the things. But yeah, no, like I said, good talking to you, and we'll I'm sure that we'll speak soon.
Absolutely. Sounds good, Eddie.
All right. Yep.